I'll have to learn sign language for you.
And did you like all red one?
Hey, Mark.
Hey, Nathan, how are you?
Hey there.
Hey, Stefan, how are you?
Not bad.
I'm super, thank you. Are you on campus today, Stefan?
I am, yes.
Are you on the guest Wi-Fi there? What just happened? The screen just went out. Can you guys still hear me?
Yes. Yeah, I can.
Okay. Something's weird is going on.
Is this better?
A little bit better. Sometimes when you're on like the
Oh, now he went out.
Oh, yeah.
Oh boy.
so sometimes when you're on the when you're not on guest at Lawrence Tech, Stefan, it's not a very accommodating Wi-Fi network. Have you noticed that yourself?
Honestly, I've had bad luck with both of them.
You're not making my point.
I'm sorry.
I have. I've never used the main one. Yeah, the guest one works better for me too. Let me make sure, Dan. So Dan is running the class sessions this week. See, I think I saw Trevor, Richard. Okay. Roger, I met your teammate finally last week. That was
I
glorious.
know.
That was glorious.
How did that go?
It was well. It went really well.
I noticed he was sitting very far away from you.
Yeah, but then I made him sit right there in the cockpit, right? Like he was flying that jet with Dan right next to him.
That was my idea.
And he was trembling.
Put him on the spot.
I put him in the spot. And then I kind of hovered over him. Like I was right behind him for like an hour.
So the only one left is Nora now.
Nora is next. Nora, what are your plans? Are you coming up for critical practice?
Yes.
So, okay, here's the thing. I'm attending a conference in. So you're here for 4 sessions.
That's correct. Yes.
And the one in May is the one where I'm actually going to be in Savannah. So, you and the other Texan that I had this year, who's from south of Houston, and another student, but from Quebec, or no, Ottawa. I am going to rendezvous with you guys in the June session, like June 1 to 3.
Oh, okay.
All right.
So it's the second weekend. Yeah, it's the second weekend.
Not.
Yeah, because the first weekend is the 17th through the 20th, and then the following is the 31st through the 3rd.
Oh. Well, but that's really the first. That's the first weekend in June.
Okay. Mm-hmm.
Right?
Yes.
So I'm going to try to find my way over to campus sometime between the 1st and the 3rd. And I'll let you guys know.
Okay.
All right, great. I see that Dan is here, and I'm going to hand the mic over to him in just a moment. I want you to all hear that we're going to have the regular class sessions this week. Professor Farrell will conduct them and moderate them insofar as he has things that he wants to speak with each of you about each of the teams. And we'll use the sign-up list, right, that we have out there for you to run those sessions. The second thing is next week is Crunch Week, so we will not hold classes that week. I actually do have a lecture that I need to give on Thursday, the 19th. So I cannot meet with you that night if that were to be your need. So I can meet with you more or less any other evening or over that weekend. But from my own experience, you guys, I'm the last person that you want to talk to during Heck Week, during Crunch Week. So the way that it should stand is that you'll contact me in writing if you need to meet, and we'll set up a time where we can do that. We're less than 2 weeks away from Pencils Down, which is the end of the day on Sunday, April 22. I say this all to you again and again and again because each week I get somebody asking me, when do we turn our projects in, and when do we have the reviews? And we have the reviews on Tuesday the 24th and Thursday the 26th during normal class times. I've arranged for critics to staff those sessions for you, faculty, architects, and out-of-town architects, along with your core faculty. And then we will have our final wrap-up session 1, 2, 3 weeks from tonight. So that's the immediate timeline, and I will now turn it over to Dan unless there's any questions. Hearing none, Dan, you have the floor.
All right, thanks.
You're welcome.
Appreciate it. Professor Farlow and I exchanged notes about this week. We both agreed that the predominant content that both the lab and the studio have are related to the same topic areas, and so there's a lot of overlap there, as generally is expected as we reach the end of the term. So there was a general agreement that we could basically use your recent Module 3 lab as our talking points for today and Thursday, because we're both basically looking at the same types of content areas, and we could weigh in on them based on your recent submission. So that was the reason for having the lab this time presented. I know in the past we really haven't talked about some of the labs as much or had presented them. By now you probably would have seen, if you've been looking in your email, the last Module 4 for lab. And to clarify that, most of that basically is a continuation of Lab Module 3. So I recognize that not everyone has completed some of the assignments from Lab Module 3, and that you'll continue to work on them. Or if you have, you probably have to go through some revisions, and you're going to be doing that as well. So there's really not much that's been added to the lab assignment, so to speak, per se, at this point from the last Lab Module 3. And as I understand it, with the final presentation that you will have will combine your lab module work as well as your studio module work. So they are jointly done. Now, how you organize your booklets and what order you put them in, I'll probably defer to Professor Farlow to decide that. So, and you may not utilize everything you've prepared. So you might have some things that, for example, might find their way into an appendices at the back of the book, but maybe they're not necessarily something you would present in your final presentation, but only be there because we've asked for documentation, or maybe a question comes up and you need to refer to it. So keep that in mind. In that regard, probably a few other comments I'll be hearing, you might hear about today would be some ways in which you might want to edit some of your documentation that I noticed in the lab. In particular, some cases, there's probably some images or diagrams or drawings that are larger than they need to be. They certainly can be condensed down. I don't think they need to be at the size or the scale they've presented. So there could be some ways to help you pare down or edit some of your work as well. One of my other points that I think I made in the assignment that I would ask you to think about carefully, and I know other faculty generally feel strongly about it. If you show something on a drawing, whether it's a diagram, an image, whether it's a chart with data, you should be able to speak to its content. And I would say sometimes when I ask questions, and it's not just your class, but others as well, I've said, well, tell me what that means. Explain to me what relevancy this has to the project, and what does this factor mean and that factor? And I don't have an answer. And that's problematic, right? I mean, if you're putting some information out for someone and you're going to be representing essentially what and how relevant that is to the project, you should be able to speak to it. Does that make sense? So I'd say be careful of that. So if someone says to you, what is that element of the HVAC system? What does it do? Why is it there as opposed to anywhere else? You should have an answer. If someone points out something on a wall section and they ask you a question about it, you should know what it is and why it's there, what function it has. So keep that in mind. Lastly, I would think, though, today and from now forward, anytime someone puts something on the screen as an image or something that's been produced, the person who produced it is going to be the person who talks about it. Does that make sense? You should not be suggesting that someone in your team is kind of the PR salesman, so to speak, for your project. That's not how it works, right? We're looking at competency and knowledge here. So that if you produce that drawing, that document, that data, you should be the person presenting it and speaking about it. Does that make sense? I think we're in agreement on that as well, Professor Farlow and I. So keep that in mind. So for today, I'd like to take some time to run. I think we outlined possibly 4 teams. Is that right? I think it was Cody, Richard, Trevor, Alec, John, Stefan, Caitlin, and Casey. Is that correct? I believe so. And I think Cody and Richard were first. Is that right? Okay, I see. Got a thumbs up from Cody. So what I'd like to do is do the first 2 teams, and then I'd like to take a break for about 10 minutes and do the last 2 teams and try to wrap it up about 8:30. So I'm sorry, I don't know that what the best time frame would be. So Mark, what do you think our time limit ought to be for the 4 teams today?
Well, the times that we had on the schedule get us finished, or I think by around 8:30, don't they? So we
How
could,
much time per team is it? I'm sorry, I didn't
I
look.
think we usually, guys, isn't it usually like 35 minutes?
Okay, and that includes comments?
Yep.
Okay.
Yep.
So can I ask you guys to keep your work, keep it down to 20 minutes for presentation and allow us 15? And then I think I would ask you at the beginning, please let us know, are you willing to take a question as you go through, or do you want to just finish and we'll take questions at the end? Otherwise, we sort of don't know if we can interject. Does that make sense? Okay, so I'll keep the clock here. I'll be watching the clock. So if we've got Cody and Richard up, I'm going to ask you to go first. If there's any questions at the end of the session, please just feel free to ask them. As Professor Farlow said, like Crunch Week, he didn't necessarily think he'd be available. I will be available if you need to talk about something, you want me to review something with you. If that works for you, I can be I'll be available those evenings, and we can set up the hangout session.
Perfect.
Moving forward, Cody, you on the floor?
I do have it screen shared at the beginning of the presentation.
Thank you. Go ahead.
If I could just quick plug in here, the field trip out to the Earthenworks farm is tomorrow. If anybody's interested, please let me know. Thank you.
Good.
So also Richard he has an issue with his voice. He's not feeling very well. So I will try to talk to a couple of his slides, even though you had just brought up the slide issue with people talking about.
I think in this case, you're going to have to.
Yep. So just to make that known. So starting off, get into our structural system. We have the rammed earth that goes throughout all the floors of the building. At the garage and main floor, we have concrete systems. And then up above that, we have heavy timber. And those two systems work together with the rammed earth.
I'm sorry, Cody.
Sorry?
Will you take a question now, or do you want us to wait?
Let's take questions as we go.
Okay, can you back up then?
Yep.
So I see maximum height, maximum area. Now, is that what the code says, or is that your project?
Code is actually not 85. Oh wait, I'm sorry. As reference to the heavy timber as a structural use, that's
Richard's texting. He says it's the code.
Yeah, that's just the code.
So do you understand? My next point would be, so what is your project's height and what is your project's area, right?
Yep.
In other words, you say code says this, and this is what we are. Obviously, we comply.
Okay, so we'll include that information on this slide then.
Yeah, I would say always sort of look at the code conformance as saying there's two parts to it. What your project is, but what does the code require?
Right.
Thank you.
Okay, cool. Next slide, we get into the structural systems. We have the foundation plan for our building and the main floor plan as reference to the retail space and the outdoor space in our building. The main floor, we are using a lightweight concrete a metal deck system for that. And the two-way and one-way slabs are shown on there. And then the red outlines the lateral resistance that's found throughout the rest of the floors above.
Okay, so two questions. I misunderstood. I thought that the lower level was concrete. Is that correct?
Yes.
Then I'm sorry. What is the usefulness of the metal deck?
Just as a system for just as a flooring system.
But a concrete poured in place, I just would wonder why you wouldn't use a concrete slab. Does that make sense?
Okay, we'll double check that.
I mean, I understood if you had a steel system and you wanted a concrete concrete floor, so to speak, that you'd have concrete, but and steel. But in this case, if you're basically a concrete trade doing the work, I would think you would just stay with concrete.
Okay.
Secondly, take a look at the red lines, which I guess are indications of cores or shear walls, correct?
Yes, those are shear walls.
Okay. If you imagined looking at that plan, and you know the concept of a centroid, right? From basic structures, what a centroid is.
Can you explain that to me a minute?
Okay, when you looked at a structural section, a structural member and cross section, I said, "Where's the centroidal axis?" You remember in basic structures how you did that?
Yeah. Okay.
Let me rethink or phrase that. When we look at lateral force resisting systems, let's say in advanced structures, we talk about where's the center of stiffness in the building frame. The center of stiffness is generally coincident with the location of the main lateral force resisting elements. Torsion is not a good property. In other words, you don't like to see imbalance in the location of lateral force resisting elements, because if you have an imbalance, it creates torsion, and torsion can create an acceleration or an increase in magnitude of lateral loads.
Right.
If I look at your plan on the right, and you tell me, do you think the center of stiffness in your plan is balanced or is not balanced? In other words, is the distribution of the red lines representing lateral resistance equally dispersed along all edges, or is it concentrated on some regions or edges only?
It is concentrated on some regions or edges only.
Okay, so you understand my point then, right?
Yes, and you did bring it up before when we talked about
Yeah.
using that Ramsdorf wall as a lateral resistance.
No,
load.
I understand that, and I'm not saying that you can't do what you're doing, but I think you need to augment. I think you would want to augment that with other means of lateral stiffness.
Yes. So
those
like,
and what could those be?
so moment connections with our
Right.
heavy timber, right?
Could have moment connections. Do you have rigid connections in some of your bays, or?
Yes, we have. We actually detail that later on, the rigid connections throughout heavy timber.
Okay, so I guess what I would say is they're either in all the bays or they're in some of the bays, right? So moment resisting connections could be in all the bays. They may be over designed in a sense for that, but they would also reduce your moment values on the beams, and that's a good property. So that's not a negative. So I would ask you to think about, as you document lateral resistance, you may be you'll need to indicate other means of lateral resistance in this frame, such as along column line G, okay, or column line B, I've got a row of lateral restraint because the connections between beams and columns are all rigid. Does that make sense?
Okay, so what the issue here is with our drawing is that it doesn't indicate that we have those rigid connections in the heavy timber beams and columns.
Right. Are they in all of the bays?
Yeah.
Okay, then you definitely need to note that.
Okay.
And look, guys, I'm not adverse to having a 3-sentence description that describes something in a little bit more detail, right?
Okay.
And you can even use that as your prompt if you're presenting it, right?
Right.
This is what I need to say. 3 sentences. This is how this system works.
Okay.
Okay.
Thank you.
Let's go back to the notion of size and scale again. I know I appreciate this because I can see it on the screen, but I do think these could probably be about half the size they are and still be legible and effective. That makes sense. I'm just trying to give you clues to how you can condense, all right?
Yeah.
Okay, thank you. Go ahead.
We get into the next slide showing their typical residential plan and our garage plan. Obviously the same style we had before. Comments on the showing how the moment connections in the columns is noted. For the typical residential plan, we have the heavy timber beams and columns shown along with the floor trusses shown in that as well.
Is this a mass timber system?
Everything except for the floor trusses.
Is mass timber?
Yeah.
Okay. So I guess just a graphic issue. When I see the black lines there, that doesn't represent like a joist, does it?
What black lines are you referring to?
The ones where your cursor is right there.
That is the floor truss. Those are the floor trusses.
Okay, but maybe I'm wrong, but wouldn't mass timber have a very thick floor and then it could span fairly large distances? Almost like a concrete slab?
The distances for thickness of the heavy timber, or mass timber, I guess, actually got too thick for what
Okay.
we could use per floor. So we ended up going with floor trusses linking up to the heavy timber beams over to the heavy timber columns.
And
Okay, so
what's
it's
the
not
spacing
really
of those
TLT.
trusses then? What's the spacing of those trusses?
The spacing of those trusses is 1'6" on center.
Okay. Lot of them, I guess you have a choice as to whether or not you could increase the thickness of the plywood and space them farther apart. Remember, more pieces and elements in the system, the more the cost will go up, both on materials and construction. The other issue with this would be sound transmission and vibration, right?
Right. And we do call out some points in the sections, detail sections where we include material for that.
Okay, and I'm not sure I understand. I guess there are balconies there, right?
Yes.
Do you understand how they're going to be supported?
Yeah, we have a detail for that as well.
Okay, they're not exactly clear. All right, please go ahead, sorry.
And then the final structural system is the roof plan layout.
Okay. As I said, once again, I think these could be smaller, right?
Okay. Okay. Here's the structural, here's the detail of how the, because up until now we hadn't decided on a particular skin for the side of the building that isn't rammed earth. But this is what we've come up, what we have decided to use anyways. It's an Oco skin system. And this here is the detail of how our, the balcony works, along with how the skin is put together.
Go back to the plan view of the framing for a minute, or the typical residential floor. Zoom it. Zoom the upper right corner. Zoom the right corner on the between 6 and 5, and G and F. To the right. Yeah, we're 6. Yeah, right there. Zoom that more.
Okay, just a second.
Show me the balcony there. Okay.
Yeah.
So I'm looking at what look like to be the large trusses parallel to the balcony, correct?
Yes.
Now, when I look at your, can you go to your detail? Zoom out, please. It appears to me,
Sorry.
detail, please. I'm sorry. It appears to me on the right side, the truss is perpendicular to the balcony.
Good point.
Okay. I'll let you go from there.
All right. Any more questions related to this?
Well, I'm glad you've got softening shown there. And I think, as Professor Farlow pointed out last time, there are some issues of insulation. I'm not sure you need to fully insulate the balcony per se, but I think you want to insulate it close to where the exterior wall is. Does that make sense?
Yeah.
And also, of course, there needs to be the insulation shown in the walls, right?
Well, they do call it out. They just don't hatch it, it
Right.
seems.
And also remember what we're asking for. We're asking you to meet the ASHRAE 189.1 code for the R value, right?
Yeah.
So this might be structure, but it's a good detail also, or a wall section's a good detail where you'll do that calculation, right?
Yeah. On this particular system, we got an R value of 35.
Okay, and again, you have to say to me, you have to show me this is what 189.1 says for this type of construction, and I'm either at it or I'm above it.
All righty.
And if you want to be above it, you know, I don't have a problem with it, and I think you would be able to do that without having to worry about fire retardants in the foam or the insulation. I don't think it needs to be if it's type 4. So you might be able to push it if you needed to push it to get better energy performance. That's fine. I wouldn't go more than twice what the ASHRAE code says. Can I talk about the detail of the sliding door at the balcony?
Yeah, you want me to zoom in on that?
Yeah. So I'll ask Professor Farlow. Is that how you guys would do it in an office?
Well, first of all, the code does allow a 4-inch offset or differential between the main floor and the surface of the balcony, guys. And that's actually to everyone's advantage, particularly in any environment where you're going to get wind-driven rain, which is pretty much anywhere, and snow, which is pretty much where we are. So when you have a condition that achieves that 4-inch offset, it allows any sort of standing or ponding water or snow to be less inclined to migrate or wick or be driven into the interior environment. So that, I think that's maybe where you were headed, Dan.
Yep. Also, I want to find that I have a level base when I drop that bottom condition of the slider in, and I'm kind of wondering what that, like, I don't know if it's, you'd call it a sole plate or a sill plate would be like if there's nothing under, above it.
And so I guess this question is also starting to go to the section and what the structural system could be. I know what you're thinking it is. It's these pre-engineered wood trusses, but maybe because the balconies are so shallow, guys, that we could header off these balcony areas and do sort of incidental cantilevers that are basically 2x12s set at an elevation, right, that allows for or promotes the offset, and the thickness of the balcony could be much less because you're only skinning a 2x12 structural deck. You could, in the north-south axis, sister 2x12s, right, running north and south. You could sister 2x12s to those joists, to those pre-engineered trusses in order to let them outrigger and become the balcony. And you could header them off of the trusses running in the east-west direction, I believe.
And so while we're on this image, I'll ask Professor Farlow again. Finished balcony floor, engineered decking. Is that going to be suitable for exterior grade?
So I think what they're saying is the engineered decking is something like AZEK or
Trex or something?
Yeah, Trex, right?
Is that correct, Cody?
I don't think we specified a particular brand.
Okay, but you understand the point is that it needs to be labeled as and understood as an exterior product.
Okay.
So engineered decking actually is typically wood used on interior. So I'd be careful about that generic name.
Okay. Got it.
Also, is there a slight slope that's going to go outward and downward to the outer edge of the deck?
There will be. There isn't right now.
So again, the 2x12 sort of replacement, right, of the engineered trusses actually allows you guys to profile. I'm exaggerating with my gesture now, but it allows you to profile that deck a little bit, or you could just achieve it by sleepers, and then letting the sleepers have the profile to achieve that drainage, to promote drainage, like at 1/4 inch per foot.
So I think we're getting to the point, as we talked about earlier, you don't really have a system that's spanning creating a support for the balcony yet.
Yeah.
So that has to be understood. The rest of the things look reasonable to me. I would indicate your insulation, not just to label it, but physically indicate it.
Yeah.
And then I'll zoom out again, and then probably remember the points that we talked about in 4 different line colors. Indicate water barrier, thermal barrier, moisture barrier, and air barrier, please. Okay.
Got it.
It's in the lectures that I sent you. in the lectures with the assignment on the, remember the lecture I sent you that's on wall sections? The last PDF?
Yes.
Okay, it's all in there. Okay. All right. I don't have any other comments. I'll let you go on. It does look though to me like that typical wall section beam. The beam is really wide relative to its depth. Does that make sense?
This here?
Yeah, it's mostly square.
Yeah, it's almost as if it doesn't have the right cross-sectional shape to be a beam to have a high moment of inertia. You know what I mean, right?
I do know what you mean, yeah.
Okay.
Okay, we'll double check that too.
Okay.
Moving on.
But I guess another point on that, Cody and Richard, is wherever that beam is along the outside wall, because the wall is eccentric to the center axis of this beam, it means that any electrical or plumbing or mechanical that might come up from beneath through the floor, which I doubt you'll have in these outside wall cases, it has to cope with the width of the beam, right, as you've illustrated it. So that's why I think you should double check that. I appreciate that you want this beam to cope nicely into the vertical width, right, Richard, of the column that it's gonna intersect. But when you think about how the guys in the field actually have to install toilets on outside walls or mechanical systems or run electrical, the presence of steel or wood there, right? It doesn't matter the material, but anything that has a cross-sectional sort of heft, right, or proportion that you're showing is going to make them go crazy. And so I think that's worth just being alert to. Maybe audit the plans relative to the HVAC, relative to plumbing, and then make sure that if you need that, you stick with it. But if you can reduce it, that might be worth looking into.
And what is the secondary structural element that goes above every door or window? Starts with the letter L.
Lintel.
Right. Do you see lintels there on the right?
No.
Okay. You understand my point. And also at the top of the connection of the head of the window, there needs to be a gap. And you know why the gap is there, because if the lintel starts to sag or deflects, right, it can't land itself on the window or the door head, right?
Yeah.
It's got to have like a 1/2 inch gap, 3/8 inch gap, backer rod foam sealant. You connect. Generally, you're going to connect things in terms of those glazed elements at the jambs, but you're not going to connect at the head. The head's got to be floating.
Okay.
Okay. Mark, does that cover it?
Yeah, I think so.
Okay. Thank you. All right, please go ahead. I'm sorry. We took a lot of time on that.
Okay. This is the, I guess, rammed earth detail section from a prior presentation. And didn't really get any comments on that last time. I did talk about it. We talked about the radon of some of the rammed earth systems in it. But I guess now would be a good time to really talk about this in detail then. As far as the solution of using a concrete bond beam to distribute the load further out within the wall to get rid of the need for a pilaster within the rammed earth wall. Does that seem like a viable solution for what we've done? I have seen a couple diagrams from Sirewall that use the same kind of system. This here is incorrect. I just found out. It's not a hollow core slab.
Yeah, it's not the system that you have.
Yeah. Nope, that'll be changed.
Also, please, as you're getting to the grade condition, So on the grade condition where not very far down, but obviously certainly along the retail edges of the street, you probably want to think about having some vertical solid board insulation along that edge below grade.
Okay.
Some of the thermal loss. Now I know the parking below grade's not conditioned. I get that. So, but still a little bit stopping it so it doesn't sort of start migrating towards the slab on the first floor.
Thank you. That's good advice.
Once again, insulation looks a bit thin on the roof. Probably go back and check that 189.1 code requirement for roof insulation. It's pretty high. Okay.
Okay.
Make sure that that works. Can I zoom on the upper right?
Yeah. Green roof side.
Well, no, to the right, yeah. So, sorry, yeah. So I'm seeing the 12 by 18 heavy timber. So it looks like you cut right through the timber beam in that section. Is that right?
Yeah.
Yeah, normally when we see a building section, it's not through the structure.
Right.
So in other words, you're going to be in front of it, right? And then we see the other things that are framing into the heavy timber, right?
Right. This was just to show us how this was being embedded in the rammed earth wall.
I understand.
Okay.
And then it looks like the thickness of the rammed earth to the right side of that beam is very small. And is it stable like that?
That's still about, I guess I need to double check that thickness there.
Okay.
But embedding it in the wall, you still have probably 4 or 5 inches worth of that.
Okay. Usually too, when something's embedded in the wall, there's always a gap around it, for movement and tolerances.
Okay.
So you're showing like no gap, right? Just completely packed.
So we should provide some kind of slip, I suppose, or.
Yeah.
Okay.
And looks like a reinforced concrete bond beam is being called out there, right?
Yep.
But that doesn't look like a bond beam to me. I'm not sure where you found that image. Bond beam is kind of like a U-shaped CMU, where the top is open for grout and concrete.
Then I am mistaken in my
Okay.
assumption there. Okay.
Okay. And I think the bond beam is there also to stabilize the diaphragm. That's the roof. I don't think it's necessarily related to whether or not you can eliminate a pilaster. It's also useful, obviously, if you have something like a window or a door beneath it, right? It's going to serve as your lintel. Does that make sense?
Yep.
Okay. All right, so remember again, transitions are always critical areas for lack of thermal breaks, right? Transitions between roof and wall, transition between floor intersecting wall, transition when grade intersects wall. So be careful with those. So my point would be, right now, that upper right-hand side section of the drawing,
Yeah.
there's some thermal break problems going on there. It may be unavoidable with rammed earth. I'll give you that.
There's a good benefit to that, though, with rammed earth at least, is it takes, or I've at least read, it can take 8 to 10 hours for energy to transfer from one side to another.
Yeah, right. It's the delayed gradient transfer. Okay. All right. Let's move on.
Okay.
Sorry, way over time.
This is where we call out the rigid connections with the heavy timber and describe some of the spans we have here, the depth.
Okay. Again, you might be able to collapse some of that down into smaller charts or data and smaller images.
Okay.
Okay, keep going.
This is a reused drawing of the HVAC system and how we distribute it in the residential floor.
Okay. I think I would leave those the scale that they are, though. I think they need to be that size to see them.
Okay.
You have some rooftop units I see there, and something in the basement, right?
Yeah,
Can you label them?
will do.
I think in general, I think you might want to use a few more labels. I know you're using the keys, and that's good, but I think you need some more labels on these.
Okay.
Go ahead.
Found a system for the main floor that wasn't the vertical stack, a water source heat pump,
Okay.
because those were too small in the amount of tons they could provide in cooling. These can provide between 6 and 25 tons, and they use the same water source system as the vertical stack. So we would be keeping with the same boiler setup and chiller cooling tower setup.
Okay. And some of the data points you just mentioned, like what its capacity is, you should note that.
Okay.
And probably, you might want to rethink a little bit some of your general headings, maybe mechanical system as opposed to HVAC. And then you can call out something like, in particular, what this particular element of the HVAC is. Does that make sense?
Okay. That's a good point.
Okay. Keep going.
Then we get into the water and plumbing systems and what we had discussed before about how the point that had been brought up before about how this could potentially be used to either service gray water, flushing water, or drinking water. And we are proposing both utilizing our living machine system that through some of our emails, we did discuss kind of likely the 12,000 gallons a day being the maximum amount of water that it can filter per day. And you had some reservations about that number?
Well, I saw what you were saying, but also, if you remember, I sent you a paragraph cut from one of the manufacturers, and it had a bit of a concern about the use of this as potable, did it not?
As far as cost and worth, because it actually cited some of the people or some of the residents' potential wariness of water being treated on site instead of being treated somewhere that they can't.
And it's also your municipal code officials that are.
That too.
Right. Okay. I mean, I just think I think you need to be just right, cognizant and aware that the potability question will probably come up again. Okay.
And I will try to make sure I'm ready for that.
Yeah, and it may be a tough one to get past because, I mean, if a company that makes this product is putting out a caution note on that, I don't know I don't know how you get past it. So probably also.
I think it needs to be done either way. And if the company is putting out a cautionary note about it just because of one municipality, I don't think that Detroit would be all that far away. We have Flint is a very good contrasting example as to how municipal water sources can be kind of an issue. And I think having something like this, we could make an argument for it within Detroit. Just saying.
Yeah. Well, the other side of the coin is they're going to be extremely cautious about what they approve because of Flint. Unfortunately. Right. Look, I'm on board with all of this. I love the fact that you're doing this. So I'm not arguing this from the skeptic standpoint, right? I'm just saying that if there are some cautionary notes out there, you may have to be careful with some of these. But that said, I'm glad you've got it together. I realize that the tanks weigh quite a bit, don't they?
The tanks themselves would weigh quite a bit, yeah. And so the structure on there needs to be improved.
Right. That's my next point. Those water tank regions of structure are going to probably need to be bigger and thicker and heavier than they are now. Okay.
Sounds good.
Just got to carry that. Sorry, go ahead.
And the other stuff I detail on here is just the process that it goes through. So from the settlement tank all the way through the biofilm and oxygenation tanks.
So, you know, one quick suggestion on structure. You see those big vertical walls you have dividing the tanks?
Yeah.
That could be what's sometimes called an upstand beam.
All span beam?
Yeah, they use the term with shear walls. It's not common. Basically, that whole wall is going to become a beam that's connected to two columns on either side.
Ah, okay.
You know what I'm getting at? You're using it to carry the load. So you thicken the slab down beneath that, and that upstand beam, which are those walls, connect to columns on either side where your glass cut is, and that's how you transfer that load.
Okay.
All right, go ahead.
That sounds like a great solution for that. There's not really much else to kind of discuss on this particular drawing. We'll move on. The water and plumbing systems. This is the fire suppression here.
Okay.
And how we've laid it throughout the apartments and the sprinkler heads within the apartment and our hour separations.
And I probably would say you'd want to call out what your target is, like it's NFPA, and I can't remember the acronym code for it, but
13.
13, thank you. You probably want to call out that's what you're indicating here, okay?
Okay.
I like the dashed circles, guys, that show the sprinkler spray realm. That's very clever.
You don't need to have a sprinkler head in a restroom or bathroom.
No? Okay.
No, I think in the information I sent you, I checked on that. Not needed.
Okay. Thank you. Next slide, our construction wall sections and details. These are some of our window calculations for our different facades of the building.
Again, I would say compare that to what the 189 code recommends, right? A certain percentage glazing max, right?
Yep.
And are you above it, or are you below it, or are you close?
We will make sure we can compare and contrast those.
That's your benchmark, right?
Yeah.
Okay.
And just more that we need to contrast and compare with.
Okay. All right. You know, again, in the interest of time, I'll have to look it over further, but thank you.
Thank you. Is that it? 624.
Are you done?
Yeah, that's all we have.
Okay. Yeah, Mark, do you have any other comments for them? Mark, are you with us?
My only point is that on the upper right section drawing that we left, where you brought up the point about insulation thickness based on 189.1, I have a feeling that, you know, 4 inches may be the base dimension. It actually may be more than that. I think that's what Professor Farrow is saying.
That's what I'm getting at. I don't think.
But also, right, the roof is going to have to drain, and usually the insulation provides the drainage profile, right? So we'll do saddles, guys, to promote that drainage. So there actually may be 6 inches of base insulation that achieves the design value that you need up there, but you may have another 6, right, to get that drainage to the low point, which is where the where the roof drain is. My point is that ultimately that parapet may need to run up higher vertically,
right?
And so that's just something that you need to be alert to. You all need to be alert to that.
In this particular detail, we used a 1-inch drainage substrate on top of the waterproofing barrier. I didn't know that it was typical to use the insulation as the drainage layer.
Well, there's 2 ways to do it, right? Like if you're doing a 1-story Kmart, do we even have those anymore? So Best Buy, no, we don't have those anymore. So if we're doing a 1-story commercial building, right, we'll profile the steel joists, right? They will have the slope. They'll have a high point and they'll have a low point, right? So like the high point might be on the outside walls, the low point might be an interior column line or column lines. So the steel provides that drainage. and the insulation can remain constant. But in a building where you might be enjoying the roofscape, you might be using it, you might be, you know, occupying it for social or assembly activities, then, and if you're not profiling the structural system itself, then you have to achieve that drainage with the insulation.
Okay.
Does that sit well with you?
Yeah. I did draw this with the recent knowledge of talking with the university architect, and they were discussing the green roof on top of, I can't remember the building name, but how they had,
Taubman.
yeah, instead of using, they were worried about penetrations through the insulation layer. So they had used a different layer beneath the insulation, so that no matter how the insulation was penetrated by shovels or whatever may happen to be on there, that they didn't get leaks.
Mm-hmm.
And I tried to kind of copy that idea.
Mm-hmm.
There are some. There is a type of system that I can't remember who makes it offhand, maybe Certainteed or someone, but it's basically a green roof and it's a tray system. So it's meant to sit on the existing roof that you have. And it's not an intensive green roof, it's a non-intensive green roof element. But basically you would drop down these trays with the earth and the plants on them. And I don't know how large the trays are, you know, 3x3 or 2x2. And that forms the green roof element. And then also, then you can lay down walking elements. So you could take the, you now make wood decking, exterior wood decking that's like 12x12 or 24x24, and you just drop them down and you can walk on them. So that's the walking surface.
That is interesting.
I mean, it's supposedly less costly than these systems, and also it allows you to have the flexibility to really design your roof the way you would normally design it. Does that make sense?
Okay.
The water just drains around the trays and through the trays. And the same with the decking you drop down. Water goes around it.
Okay.
The exterior decking that they make these out of is made out of typically eucalyptus wood, I think. Maybe sometimes a redwood. But they're able to withstand the elements. The other issue is you get to reconfigure it. If you want to change your whole green roofscape, it's just like a puzzle. You take it apart and put it back together.
Or if a series of trays, and they're literally like the trays you get at the nursery in May, right? When a tray and its plants die out for whatever reason, you know, you can replace the tray itself. Live Roof outside of Grand Rapids is a local company that tenders this product to you guys. You could look at that.
Yeah, I know the guy that started that. He gave me a couple tours of both the one that they did at GRCC and then nearby church.
Great. Yeah, good group.
Yeah.
They're also doing live wall, which is interesting too. That's another conversation.
Okay. I think we've kind of run over our time, but unless there's anything in addition you'd like to talk about, and I think we could move on to the next team.
That is it. We appreciate your comments.
All right, you'll get more from us as we go further. Thank you, Cody.
Cool.
Richard.
Thank you.
Okay, who's up next? Who is up next?
That would be me and Caitlin.
Okay. Who wants to present?
Caitlin has the file, I believe.
Caitlin, are you ready?
Yep.
Can you turn your camera on, Caitlin?
Yeah, your camera is turned off at the moment. There you go.
Okay, so we started off with our structural plan for the garage floor, and I realize there's no dimensions on this. They are on a later floor plan, but I gotta add them to this file or this plan.
Yeah, I would say if you're going to show, I mean, the question I would have for you is, you know, with Professor Farlow and I kind of asking for some similar information, right?
Mm-hmm.
So, I mean, there is a way that I think you could use a drawing like this that could probably represent structure and maybe the architectural drawing at the same time. So if it makes sense to do that in your presentation, you could do that. Otherwise, if it's just going to show structure and it's going to be combined with other structural floor plans, again, I think it'd probably be half the size and it's still legible.
Yeah, I wrote that down.
But the notations that need to be there are about structure, right?
Yep.
So it's column bays, the column sizes, connection conditions, right? I'm not even interested in talking about whether there's, parking adequacy, right? That's not the point to look at the drawing, right?
Yeah, on my screen, I grayed those out. I think when I converted to PDF, they just kind of got a lot darker, but they were kind of grayed out in like the background.
There is something that's a bit odd about this. Like I can't see the exterior wall.
Okay.
You understand what's happening here? Look at your drawing.
Yeah.
Column line F, I would think would be farther to the right about 18 feet, right? Column line 1 would
well, no, because the site plan line is where the where it ends on this drawing, where the parking is touching, but then our building is offset off of the
okay, but there's going to be a retaining wall up there.
I mean there should be a wall there, but it's just
and it's going to be structural because it's a retaining wall and it's going to pick up lateral loads, right?
Yeah.
And it's got to transfer itself back to some structural elements that resist those lateral loads, right?
Yep.
Okay. In other words, let's say the beam along column 1, would it not engage that wall on the outside?
It should.
Okay. And there might be a pilaster there because it's got a small load, right?
Yeah.
See what this looks like, guys, is if you can imagine like a pergola or a trellis sitting, in the footprint of a much larger space or realm, which is the building footprint. So, right, Professor Farrell's right. That beam that runs along one needs to engage the eastmost wall and the westmost wall, as well as the one along 2 and 3 and so on, as well as A, B, C, and so on. You actually have 2. Oh, you have an A, 8.1. I see that now. Okay. Yep. What I liked about the column sizes, the column bubble sizes on Richards and Cody's, is they were a little bit larger than customary, especially if you're going to reduce these down. Scaling up the column bubbles so that critics can refer to them in conversation would be courteous.
And can we scroll down to the lower right, please, and zoom in? And I'm sorry, I'm going to, pick on things here, but we're getting to the end of the semester, right? So, Professor Farlow, do you understand how that stair would work? Or is there a structural member going through the stairs?
Well, it sure looks like the angled column or beam that runs parallel to John R is slamming into the stairwell. So there's either got to be another column at the stair wall to receive it and end its run, or we have to slide the stair.
Okay, yeah.
You understand that?
Yep.
So that beam has to get headered off. It has to end.
Okay.
And transfer that load. So a column there, a pilaster there, right, to receive that thing.
So I while we're on this topic, if I cut a section through this building and I look at the area to the right of the wall along column line 1, going up to the property line, obviously there's going to be a slab roof there, correct?
Wait, along column line 1.
One that's at the top.
A little bit.
Yeah, go up to the top. Between column line F and the far right hand edge of your parking deck.
Yeah.
Right, there's a slab there, correct?
Yeah.
Yeah.
Otherwise, water is running into your deck.
Yes.
Right. And I don't know, is that slab part of a floor above, or is it part of like an outside green space or walking area?
There would be walking area.
So it's outside?
Yes. Well,
no.
A little bit of it is. If say like so F is offset about 2 feet in from the wall because of like our first floor isn't the same as the residential floors. So the residential floor, so that's about 2.5 feet extra to the right where the residential floors would be, but then past the 2.5 feet towards the sight line would be like the sidewalk area.
Is the load going to be transferred from the residential floors up above down adequately?
It should be.
I hope so, but let's go to the next level above that then.
So then, yeah, then you can see like where to the right of the column, that's where the residential floor, or not the residential, the storefront is.
So that part of the slab that's the roof of the parking deck is enclosed, right?
Yes, that part is, yes.
And then there's the wall along the on the far right-hand side to the right of F, correct?
Yeah.
And that wall's going to sit on the slab there, correct?
Yes.
Or is it sitting on the basement slab, or on the basement wall?
There's no basement wall there. That's farther over to the right.
Yeah.
My point is that that first floor, let's call it storefront or whatever it is at the moment, probably has to have a thickened beam underneath it
To receive it.
to carry that. It's a transfer beam to carry that load of that wall. Okay.
Yep.
And then it's going to carry it, let's say, to columns 1 and 2 and to columns 4 and 5.
Mm.
And that means column 1 has like I'm trying to look at the word here, like a cantilever stem parallel to column line 1 connecting to that wall. Column line 2 has another stem coming off of the column engaging that outer wall. I know this may sound I'm maybe not clear orally, but do you understand what I'm getting at? There needs to be like an extension of the coming off the column, like a thickened beam, like an overhang beam that's going to grab that edge of that wall line and carry it back to the column.
So say we took column, or
tell you what, why don't we have this as an email discussion later?
Okay, that's fine.
Let's go to the next level though. I want to see what's happening next.
But I do think, since you guys are local, since you guys are local, you may want to bring the Revit model in on your computer, guys, and walk through this with Professor Farrow and allow him to see the sandwich, to allow him to appreciate the alignments, right, that you're proposing here.
Okay.
I think it'll be slightly clearer, because graphically we talk about sort of oral obfuscation here, that we're not making our point very clear in words, but I think you're not making your points very clear in the drawing, right? The painted stripes, for instance, in the ground floor parking realm are really distracting in a structural drawing.
Yeah,
right?
and also column line F is column line F all the time and always in that location.
Yes.
Yeah. So let's go back to the prior drawing.
And it's certain number of feet away from E.
Okay, so now there's something over there that's structural to the right of column line F. Do we understand that?
Yeah.
So there needs to be something out there called F1.
Okay.
Okay. Does that make sense?
Yeah.
Okay. All right. Let's keep. Also, the same comment I would have had then for Cody's team is, where's your lateral stiffness? How do we pick up wind loads? Are you going to get to that?
Well, so it's hard to see on here, which is kind of obnoxious, but I did highlight the core areas, and then I haven't chosen which walls in particular, but I have.
I see you have some common demising walls that are consistent throughout column 5 and 6, right? And 7.
Yeah, 5, 6, and pretty much the entire.
It's too bad 2 doesn't line up, but that's okay. It would have been nice.
And yeah, so 5, 6, 7 is the same throughout, and then the entire hallway on the east wing it lines up through all 5 floors.
And your structure description, you didn't call out the code issues yet, And you didn't call out what it's made of. Is it concrete or steel or what?
This is steel on the residential floors.
The concrete below?
Yes.
Okay, you got to call all of this out, right?
Yep.
Are you using the upturned beam for the steel to reduce the floor depth?
We were using. I looked at that calculator you sent us.
I know, but of the different systems options that I gave you guys way back in module 3 in the studio, I said there was a few options for structure. One of them was steel. It's called an upturned beam. It's similar to the delta beam, but it's a variant form of it for steel. Did you look at that?
No, we did not.
Okay. That might be it. That might be a way to. I mean, I don't know if you make that change today, but or should at this point. But let's just keep going. That would have been a way to reduce your floor-to-floor depth.
Okay. And then we were just doing typical bolted section. Since we're not using rigid frame, we're just doing.
That's a pin connection.
Well, yeah.
Right, and it's way too large. I mean, obviously, it's just.
I figured.
Yeah, I mean, you know.
When you mentioned it at the beginning of class, I was like, oh, I know exactly which drawing we need to scale.
Right, and I mean, obviously, you know how to draw that for your real project, right?
Yeah,
So it would make more sense for us to see it in the context of your real project, right?
Yeah, okay.
Okay. Go ahead.
And then I think we get into plumbing. Okay, I was like, why is it not loading? So we have a main shaft with HVAC and plumbing at the alleyway, and then that would have the cold water supply, hot water supply. And
so you have a central unit then?
Yeah.
Okay, so you need to call it out. You probably ought to tell us what that central unit is. Is it a high-efficiency gas-fired boiler, right? Does that make sense?
Yep. And then those pipes are just running underneath the slab in the drop-down ceiling, which I think maybe the section could be blown up so you can see that, or at least a little bit larger so you can see that.
Okay.
Okay. Dylan.
Sorry.
So then I just started laying out sort of a roof drainage plan.
Okay. So when the roof goes to the drain goes to that point, inboard roof drain, where does the water go from there?
See, that was this is how I started it, and then I'm kind of think maybe having it run towards the courtyard and then collecting it somewhere in the courtyard.
Right. I'm just saying there's got to be like a vertical downspout.
Yeah, I know. Well, this is just like after looking at this and like I don't have like this is obviously like my first one.
I understand.
So I was just thinking about having like downspouts on the courtyard side and then having like a collection basin.
Yeah, but when you show me what you're showing there, you've got a point of water collecting in something.
Yeah.
At a point, and it's got to move to some other point, both laterally and vertically. And the question would probably be, how does that do that? I mean, in some cases in the past, we saw people sort of bury them next to columns.
Okay.
They would sort of, encase them in the next to the column. They'd be encased with the finishes, and you wouldn't know they're there. Does that make sense?
Okay.
The modernists never really wanted us to see downspouts, right?
Yeah. Okay.
But we also enclose them for a couple of reasons. One is they make a lot of noise, right? So during a rain event,
right,
especially since they're PVC and not like cast iron, right? They're going to make a lot more noise, and you might think that that's a romantic sound, like rain on a corrugated metal roof. Some people are irritated by it, but the idea of indicating a couple of moments or points where this runs laterally and then to a vertical point, like in an encased area within the stairwell or at the south end along the alley where you have your HVAC. Those are points where you home run some of those drains. The other thing that happens when you guys do these roof plans, and I appreciate that you've done this, but you also have an overflow drain, which is a few feet away from the main drain that has sort of a capacity to receive water on a flooded roof, and that can drain right out the side of the building. And there's two schools of thought on that. One is to take a pipe all the way down to grade to spill onto grade whenever that overflow drain is necessary. But when you go through value engineering conversations, they're going to say, wait a minute, let's just let it spit up high at the roof line. Do you know what I'm saying? When it's overflow. I'm only talking about overflow right now. In either point, whenever you see water coming out of an overflow drain, you got a problem, right? You have a real problem. That means there's a pool of water up on the roof, and someone's got to get up there really quick to mitigate it. But that's why you'll see those little lamb's tongues low in the bushes around some buildings, or up high at the roof line in others.
Okay.
Yeah, the other approach would be the high point of the roof. Let's say we see where column line 2 is on the
D,
right side.
Yeah.
You have a high point just below that. If you took that high point off, then both the drains that are along column line E to the upper right could be draining that same area.
Yeah.
In other words, one's your overflow.
Okay.
That makes sense?
Yeah.
Could that work, Mark?
Yeah, that could. There is if you go to drastic standards, right? There is a way that you can compute the number of roof drains that you have. You've got them drawn conveniently within the bays, but you actually may need more, or you could only require fewer. So I would double check with graphic standards.
Okay, keep going. Thank you.
And here is the exterior wall section. It has since been updated again. And I'll be going to see Eric on Thursday for that as well. But
graphically, Caitlin, I definitely appreciate that you're thickening the lines around material conditions that you're cutting, but you're kind of drawing it with a charcoal briquette.
Yeah.
Which is really, really thick. It needs to not be that thick, because what's happening,
them all down.
Yeah, what's happening is it's obscuring kind of content in here.
Mm-hmm.
Yeah, so I can't see where the steel I-beam is. I can't tell where the corrugated metal decking is.
Mm-hmm.
And those would be a couple things you want to identify real quick, right?
Mm-hmm.
Also, the concrete beam is eccentric of the column. In other words, the center of the web does not line up with the center line of the column. Do you see that?
Oh, that beam is angled. So should we have like a dotted line that?
Oh, it's kind of like the one Foster had then.
Yeah.
That would make sense.
This is that column line F. So
yeah, and also, I'll be honest with you once again, as I referred to earlier, I don't see as we talked about with Cody, I don't see how that cantilever balcony is supported.
Yeah.
Okay. Does that make sense?
Yeah.
Okay.
And in this case, I think the section's cut not at the balcony. Is that correct?
Yeah, it's cut through the window.
Yeah, so you would like make that stuff real faint, the balusters and the balcony beyond. But you're also showing the line work as solid when that balcony slab goes through the wall. So that should not be there. That line work should not be there.
But I would actually say I would prefer that when we do these wall sections, and I know it's a pain, but cut them through the balcony, because that's what we're going to try to understand, how that actually works. The rest of the wall will be easier to understand, right?
Mm-hmm.
The balcony projection, that's more difficult. Okay. Once again, I'm looking for insulation, and because the lines are so thick, I can't really understand how curtain walls and windows connect. So, but I'm glad you're boxing out the areas along the outer edge, like we talked about last time.
Mm-hmm.
And then Caitlin, I don't know if you saw my note before we went live, but I still feel like the window itself as a condition needs to sit on the studs, not on the insulation. So I think that has to push in more.
Yeah, I changed it.
Okay, and that also means that the horizontal conditions of the window, which we call the lintel or head, and the sill, right, need to be deeper, right? So do the jambs that run vertical, right? But those are opportunities, right, for you to emphasize their presence on the skin. And I'm not just talking to you guys. If you've ever looked at some of these more contemporary buildings where windows are highlighted, think of highlighting in terms of like the color orange or the color yellow, where the window becomes kind of like a picture frame or an exaggerated sun shade, like a brim or a blinder. You'll see this in the work of some architects, David Baker, Loha, for example. Some of the very case studies that you guys have pulled up, those are exaggerations of or extensions of the jamb. So those are kind of like design opportunities for you guys.
And there's not a clear indication of a lintel yet.
Yeah, that's correct.
And also I see insulation being identified in the notes, but I don't see the insulation in the wall in some cases.
Mm-hmm.
And then again, obviously immediately after you draw this drawing, or even before, the question of what is my R value needs to be evaluated, right?
Yes.
Okay.
And then here was an enlarged elevation to show the textures and different materials.
Right. I would say cut that in half, make it about half the size.
Oh, okay.
And then put that wall section that you've got drawn on the left side, put it right next to it so that all the horizontal elements align.
Okay.
Okay.
They should be the same scale then, Caitlin,
Yeah,
right?
they should be the same scale.
So that we can compare, right? The sectional condition versus the other.
Do you remember if you scroll to the back of that lab module 3 and you see those images I gave you? Right at the very back of lab module 3, there's about 3 or 4 of these enlarged elevations. If you haven't looked at them, please take a look at them.
Mm-hmm.
I'll ask Professor Farlow this question. Is there a way that on presentations like PowerPoint or PDFs that we can change the orientation of the slide to be vertical without disrupting the rest of the presentation?
I mean, you can organize the pages to be.
Yeah, they can edit the slide deck to have one page odd.
I haven't done this, but you can do that. So you can say, okay, all are horizontal, these 3 are vertical.
Yeah, I don't think there's any problem doing that. You just they have to do it.
Right. You understand my point.
Yeah.
This is the drawing that needs to be vertical.
Yeah.
Okay, yeah.
I don't think that you can do that in PowerPoint. I think you might be able to do it in Acrobat, though.
Yeah, in Adobe, in the PDF when you're making the final slide deck.
Yeah, if I make it InDesign, it should when I save it as a PDF.
Well, and you can just edit the Acrobat combined file after and just rotate that one page.
Right.
There's a toolbar that has organized pages that helps you.
And that's definitely the way you would want to do it. Because otherwise it disrupts the whole continuity of the presentation and people can't understand it. So thank you.
Yeah.
Again, I also don't understand what's happening at the grade condition. It looks like there's almost all glass along the storefront. Is that right? In the elevation drawing? On the elevation drawing on the right.
Oh, here?
Yeah, it looks like is that a spandrel panel?
Yeah.
No, it doesn't look like it's been changed since we last talked to you. The slab should be over the storefront, and then underneath it. But
And let's scroll over to the lower left. In the section drawing that says level 1, lower left.
Oh no.
Okay. So now going back to that issue that we talked about earlier today when you were showing me the parking structure, and grade floor structure. Do you understand the problem there? It's like my building starts disappearing into the ether at the parking level.
Yeah, there should be another wall.
You understand that, right?
Yes.
Okay.
You've got that exterior storefront glazing sitting on
transfer beam,
a consistently thick slab, when in fact there has to be some structural response to that at level 1 in the basement. That's what I'm saying.
Right, and that whole section needs to be enclosed, and it's not.
Mm-hmm.
Yeah, there should be the retaining wall to the right on.
And also along this drawing, actually would probably want to know where the sidewalk is.
Okay.
Yeah, this thing needs to be just a little bit wider. You need to show more of the interior and just a skosh more of the exterior at -9 to 0.
Yeah.
Yes.
Okay.
Thank you. And I understand these are the hardest. These are some of the hardest things you're going to be working on in terms of technical detailing at this level and for this class. And Professor Farlow and I get that. We get that. So don't feel bad if we have a lot to say. Okay.
Yep. So this was the central HVAC diagrams.
So my first question is, before you show me that, or when you show me that, you should be stating what your system is.
Okay.
Right. In fact, you should lead your discussion about HVAC with that description. My system is, it has these elements. This is why we selected it. And then proceed to explain. Does that make sense?
Yeah.
Okay.
If you guys could get these drawings at the same scale too, that will be helpful. The column bubbles aren't the same size. The buildings, the footprints. There's a different zoom factor, for example, on the image to the plan on the right, the residential plan.
Yeah, the one on the right is smaller than the one on the left. They should be consistent.
Yeah, and they should be in alignment, right? Everything should be like composed within an inch of its life.
And
I want you guys to make sure you see that stuff when you're putting it down. Pardon me, when you're putting it down. All of you. I'm not just saying it to you two.
And also, usually supply is red and return is blue, right?
Oh, okay.
So did you mean to reverse those? Because if you actually reverse the colors, what you're showing here probably is okay to a degree. You'd leave a large retail space on the right, it would be fine. Usually the supply goes closer to the outer edge of the building where the thermal loss is greater. The return is far away from it, more towards the inside. Because you want air movement across the space, right?
Yes.
So think about and along column line E to the right where the retail is, your return duct's probably going to be closer to column line E, right? Okay. And also in terms of supply to return ratios, think about a lot of the rooms you've been in on campus. If there's 2 to 4 supplies, there may only be 1 return in that room. You notice that?
Yeah.
So just think about that proportion, okay?
Okay.
So there's 2 to 4 supplies for every return generally, all right?
Okay.
Is that behind the stairs on the lower right? What is that little room there?
To the left of the stairs?
Trash room.
Yes.
Trash room.
I don't think that needs to be conditioned.
Okay.
And I certainly don't want to recirculate that air anywhere. I wouldn't think you would.
Probably not.
Yeah.
Okay. All right, so you need more of the general system descriptions, work through some of that. I'm sorry, go ahead.
Oh, no, sorry. I was just taking down notes.
Okay.
So then these are the or the reflected ceiling plan for the
So what
first floor.
what is that ceiling made of?
Gypsum board.
What is this, a ceiling plan of the first floor?
The grade
Yes.
floor, grade ground floor, Mark.
Yeah, so I mean, maybe I wouldn't show a finished ceiling in the retail spaces. I would maybe just show a general like lighting configuration, but really, I think the retailer is going to come in and lay out their ceilings, lay out their lighting loads and their arrangements based on what they're doing in them. But I do think that all of those other spaces, common spaces, functioning back of house spaces, management offices and lobby and so on, those need to be laid out this way.
Yeah, and I guess the other question would be, and I understand why you're using gypsum board in the residential units, but I'm not sure. I defer to Professor Farlow on this one. Does it make sense to use gypsum board in some of these lower floors?
So that's a good question. I definitely see an alternative being maybe a little bit more viable, you guys, like in the dressier rooms, like the lobby and management office, maybe even in the mail room, for example. You could use a 2x2 acoustic ceiling tile, an ACT, and do lighting that works with that. But everywhere else, I think you could do like exposed construction or 2x4 ceilings. And even in the corridor, once the corridor is a pure service corridor, it just needs lighting. It can be all exposed construction.
Okay.
Okay.
You follow why I say that? So
yeah.
Like a lot of things, you put value on them, right? You rank these spaces in terms of how they're used and who's going to use them. And
another issue.
And I think if you think of it that way, it'll help you design more sort of aptly.
The other issue tends to be twofold. One is the space going to change over time.
Yeah, and cost.
And two, do I need access to the space, the interstitial space? Because I might need to perform something like repair something that's broken.
Right.
And as you know, in most homes that have gypsum, that's a real undertaking.
Yeah.
But if I have my house, actually, there's a portion of it where there's a drop-in ceiling. And I'm actually thankful there is, because when something's wrong with my plumbing or electrical, I just take out that portion of the ceiling and I can gain access to what I need to. And so keep in mind, on a commercial level, that accessibility is important. I would say that the retail that Professor Farlow referred to, my experience is they have what they call a standard tenant finish out package.
Yeah.
And they just say, this is what it would be like, if you don't ask for anything unique, right?
Yeah, you could do that.
And my point would be, that's probably what you would illustrate. It's the vanilla generic.
Yeah.
This is the ceiling unless you ask for something custom.
What we call a warm white box.
Right.
Heated.
That could probably be a lay-in ceiling because it's going to be moved anyway.
Yeah.
But it just basically says, okay, now you can have occupancy because you've got the lighting and you've got heating and ventilation where you need to. Does that make sense?
Yeah.
Okay.
Hard ceilings are only going to be really found, you guys, in toilet rooms.
Yeah.
And I can't think of anywhere else in this area. So like the electrical room, mechanical rooms, the trash room, the corridors, they actually can be exposed construction.
Probably, right. Okay. So keep going. Also, I would say, look, guys, you're just going to have a notes and keys. This is what these are what these elements are in the drawing. And
yeah, you need a reference.
Because I'm asking you to be sustainable. What sort of light fixtures are there? Am I going to have a reduced lighting power density? And are these T8 fluorescents? What are they? Right?
Yeah.
That makes sense?
Sorry. Would you want like images of them or just the description?
Yeah, why not? But also telling us the explanation would be this is a good choice because it's energy conserving, right?
Okay. And here's the level 2s, or well, level 3.
So typical apartment.
Yep.
Okay.
So what's the room in the corner again in the hinge at column D4?
Is that the exercise room, or is it the?
Yeah, this is the exercise, and then laundry, depending on which floor it is.
Yeah, so that would get like a 2x4 or a 2x2 lay-in ceiling, because those spaces are going to be a little noisier, right? And we want to keep that contained, right? And so those kinds of spaces don't have the same value, right, as like the units do.
So I would ask the same question, Mark, for the hallways. Would you use a lay-in ceiling there, or would you use gypsum?
I would evaluate whether to put a ceiling in there or not, for one thing. And if I did a ceiling, I might explore clouds, like intermittent ceiling drops that allow the thing to breathe and to provide some rhythm in terms of the way you experience this thing. But if I had a ceiling in there, I would definitely do an acoustic ceiling tile, because it's an area, right, where people are going to talk louder or just talk, right, as they're coming and going from an apartment, and that disturbs, you know, other like homeowners and stuff like that. So the idea of keeping that a little bit quieter is kind of a useful thing.
And also, if that's where some things are going to be running, like electrical, plumbing, and HVAC lines,
right?
And I need to service them. I need to take that apart.
Yep.
Okay, keep going.
That,
Probably emergency lighting. I don't know if you need to show it, but there's going to be emergency lighting in the hallways and in the exit stairs. Might as well just call it out.
okay. Yeah, I wasn't sure if I should add that in.
It's not a difficult thing to do. But, okay.
That was the last of the drawings.
Okay.
Okay. Well, we're kind of at the end of the time frame, so I think unless Professor Farlow has any other comments today for them.
No, just you know, this is a really good place for you two to be in. I mean, knowing your work right now and knowing where you've been and kind of, in my mind, knowing where you need to be. The idea of making sure that you annotate these diagrams and these drawings with, you know, notations, specifications, color, not just black and white ways of referencing or highlighting things, I think is going to be a tool that will help you build the information and the content in this package so that it shows that you're capturing everything, right? And all of that stuff needs to be composed on these sheets. Try to keep the scale of all of the floor plans, all of the ceiling plans, the same scale, right? Because you're dealing with the same kind of information. They're just different disciplines. Structural could be smaller because it's referencing a basic like skeleton arrangement of things. But I think that HVAC, I think the floor plans in terms of lighting, all of that stuff need to be at the same scale.
Okay.
My biggest concern in structure is that whole shift that occurs from parking to up above.
Yeah, I think if you guys sat down with Professor Farrow and just walked him through that and made sure that, you know, everything's resolving on either the outside foundation wall or a transfer beam or the column grid below in the basement, you're going to be okay. But I do think there's some things that are kind of wonky along Brush Street, along column line F.
Well, you have two building sections shown there, right?
Yes.
Yeah.
What starts happening along column line 1 and what starts happening along column line F should be showing up clearly in those sections, and that's where you've got to put some attention to.
Okay.
Okay.
And I think the last issue is, once again, I don't know how the balconies are supported.
Yep.
So I'm not saying we can't do it. We just got to figure out how to do it.
Well, didn't Caitlin, didn't I share with you guys a section that you might look at for that?
Yeah, for the balconies.
I don't know if I drew the balcony though. Yes,
Um,
yes, I did.
Yeah, I hadn't added that mainly because we didn't cut.
You didn't cut through the balcony.
Yeah.
In my world, you would call that chickening out, right? You didn't want to get there. You didn't want to figure that out, but you got to confront that.
Mm-hmm. Okay.
Okay. All right, guys. Thank you.
Thank you.
10-minute break.
Yeah, let's take 10 minutes. It's we'll be back about 7:25.
Cool. See you then.
Thank you.
Dan, are you still there?
Yeah.
Are you free this Friday at any time?
No, not really. It's actually my birthday, and I've got plans.
Well, happy early birthday.
You're welcome. Thank you. I can do Hangouts too, and if you want to send me, well, if you want to send me some drawings where you specifically have questions, like a PDF or something, and we can do a Hangout, we can talk about it that way. Or sometimes I do a drawing and I'll just send it back to someone, send it back to you. Okay?
Yeah, that's fine.
Why don't we try that for this
Okay.
week before Saturday sometime?
Yep, that works.
Okay.
Thanks.
How you doing, Mark?
Good. Everybody's recognizing your birthday is Friday. Is that right?
Yeah, it is.
Ah, fantastic. Big plans?
Well, I'm not quite like Martin Schwartz, who has a birth fest. You celebrate for the whole week.
Oh my God.
And I'm certainly not at the Alfred Tubman level, who has 5 or 6 birthdays. But yeah, you know, it's going to be the quiet night out with my family, right?
How nice. Well, I think that Stefan was going to lead the whole class in singing you happy birthday today. Is that right, Stefan?
In Spanish? Just kidding.
Stefan's looking at me with
actually, you gotta wait till Thursday.
Horrified look, like what? That's not what I said. I'm just sitting here doing my work.
We could do it on Thursday. That'd be closer.
Brilliant.
Okay. Thank you.
I can't do Spanish.
I'm not Spanish, by the way. I just threw that in.
Maybe French.
Well, I think Desmond is because
French. I'll go for that too. I did take some Spanish and French, but it's been so long I can hardly remember it. But anyway, okay. So I think we've got 2 more left. John, Stefan, and Trevor and Alex. Is that right?
Okay, they're in the same room together.
Okay, who wants to go first?
I'm cool either way.
Okay, call it.
Trevor, you want to go?
Yeah, that's fine with me.
All right.
Give us 1 second.
Alec is going to present, I think.
Yeah, I'll take the slide deck.
Yeah.
So we're going to go to your monitor.
So we'll have speaker on yours and then.
I guess so.
Yeah.
Okay, let Alec be on and everybody off. Beat everyone off if we can. That's in the same room with him.
So John's going to share his screen, and then we'll just talk off of my.
Stefan, I think we're going to go with Alec.
Okay. I think Alex said yes to first.
Oh,
yeah, I've got this pulled up. I don't know. Either way.
Yeah, we could probably just get going. I think you got it. It might have been delayed on.
We'll just continue with Alec then. Okay, go ahead.
So I'll start with ours. I won't read all this word for word, but we have just a brief description of our structural system. I will note though that there's one change from the last time that I think we presented this. That now on the typical upper floors, our floor framing system, we're proposing to switch that to concrete on metal deck because of a conversation about the economics of the system I had with one of our structural engineers at work. But then at the parking and the first floor and then the underground floor, sticking with reinforced concrete slabs.
So going up to the upper level, why would you? I'm sorry, again, I'm confused. Why would you have the metal deck with a concrete system? Switching to all steel up above.
All steel for the beams and columns, but for the floor slabs proposed to switch to the concrete poured into metal deck.
Yeah, that's basically a steel system. Okay.
We were talking earlier in the semester. We were considering the
post tension
slab, and now we work with the concrete columns. But
I just wanted to make note of that.
All right.
So then this is our
Can we zoom out a little? Sorry. Can we zoom out a little on the plan? Okay, so that's the whole outer extent.
Yep. So we're just showing our the spans and our footings beyond are listed right now noted as 4 by 4 feet by 1 foot high. The parking ramp is sectioned off above, and then the retaining wall that borders around the perimeter of where our the extent of our underground floor reaches.
So is there a beam going from along column line 2 from U2 to U? From along column line 2 from U2 to U, column line 2.
Oh, from U2 to U?
Yes.
Yes.
Yes, there is.
Okay, so then what receives it along?
So there's detail that'll show that in a little bit more specificity later in the deck. We're proposing to pocket the beams into the retaining wall.
Okay. Would the retaining wall have to be thicker, like a pilaster, to carry that?
It would have to have something like a drop cap for a
drop cap.
Yeah.
Okay.
Yeah, and we have, it might be a little bit tough to recognize at 3/64, but we have it as 2 feet. I guess it maybe, it might have to grow even more. I would probably have to ask your advice on that, but
Yeah,
I was thinking.
Sorry, while we're on it, I would say that upper right region, like 04, 05 U to U1, there's all kinds of like offsets up there that I don't quite get, but.
That kind of influenced it.
Sorry?
What's that, Alec?
The offsets for the parking plan, right?
Yeah.
And then it, okay.
All right, then I guess it gets somehow reconfigured. All right, go ahead.
Yeah. So that's pretty much all on this one for the foundations.
Oh, but I'm sorry, but aren't there stair shafts and elevator shafts, or no?
Yes.
But this is the foundation plan, right?
Yeah, the first one was a foundation plan.
Okay, never mind. Go ahead.
So then
I do think that the inclusion or the acknowledgement of the pilasters along those outside walls, even if there are beam caps or beam pockets there, it's still probably a reality in this project.
Okay.
And along column Z.
Yeah.
Column line Z.
Yeah, I definitely think along column 1, along everything along column 1, given those spans.
Okay.
Go ahead.
All right. If you want to go to the next sheet, Alec.
The one after this?
No, sorry, that one was good. So then this is the parking floor framing plan where you can start to see, Professor Farrows, you'd mentioned the, I guess a little bit of a bizarre condition up at U to U2. That was because of the angle that we had to introduce the another column line so that we could fit the parking in, and that it would work on with the orientation of our column grid.
Yeah. I would also say along column line Z, those long beams, you do need a pilaster condition again.
Okay, I have that written down as a note. That's
okay.
And then
I if I may, Trevor and Alec, I think the like a watermark of the floor plan would be helpful. I'm hesitant to say that. At least show us though maybe the vertical core elements like the stairs and the elevators.
They're going to be chases there.
Right.
Right. They're going to have an impact on the framing plan.
Right. You can't tell the engineer what the framing should be unless you show them.
Right. Yeah, that's a good point. That's something that we have to insert in there. At this point, I think our clash detection from just modeling it out in the typical upper floors shows at least that we don't have any interferences with members going in any direction, but I'll absolutely put them in there so that they can be seen on all of these. We could probably keep going to the next one, Alec, if you're.
So these are all back on alignment. Column and beams are in alignment, right?
Yeah.
Upper floors.
It gets a lot more clean on the after we get up to and above the first floor.
Yeah, there's just that little strangeness between 3 and 4 and U1 and U2.
Yeah.
Is the beam the W12 by 26 that runs north and south on 04? Is that a cantilever after U.2? Or is that just a smaller beam there? Or a smaller column there? No, a smaller beam. Sorry.
Smaller beam is what we have shown.
Okay.
It should be called out as a W8 by.
Yeah, 8 by 10.
Yeah, I mean, my initial reaction is, can I live without U1 or U2? But I guess for some reason you have both of them, and I'm not sure I understand yet why. But once again, I'm looking for the chases for the elevators and stairs.
Yeah, he raises a good point, guys, because I'm looking down below between Y and between X and W, and I can't read it clearly. I think that's a 35-foot span.
33.
33.
Oh, sorry. Never mind. I was going to make this point that y'all are getting a 35-foot span there, and you've got it between V and U.1, but I understand now. It's just a little bit out of the realm, 35 feet.
Yeah, let's go up to the upper level and see if we can figure out why that's going on there. But guys, vertical chases are not shown.
Right. Yeah, stairs, chases, elevator cores, those are impacting this plan, because I think you're also going to want to discuss the lateral bracing, at least graphically.
Right. No, I think that's the other part of this, is there has to be a lateral bracing solution, right?
Right.
Okay.
I'm also I don't really care for the scale as a 3/64 inch, because that doesn't mean anything on my notebook or your screen. It should be a graphical scale, and there should always be a north arrow on these things. I'm harping on you now. I said that in the brief for this last assignment, but clearly you guys got to edit these things to make sure you're yellow marking or hitting all of the highlights that you've been required to sort of indicate.
Again, a graphical scale is a mandate on anything today that we do, because if you're shrinking and changing the dimensions and sizes of the image, then you have something that registers with it.
Right. Yeah.
Because the numeric value means nothing at that point.
All right. Okay, Alec, if you want to go to the next one. Did it just go back, or is this the?
This is the next one. This is the
Oh yeah, the intermediate floors, where we had that conversation about how our condition changes on the even and odd floors for the typical upper, and so that condition that Professor Farah, you'd mentioned you have reservations about in the upper right-hand corner, is because of our community space that we have, and trying to keep that free or I guess without any floor structure on every odd floor.
Again, I would ask guys, isn't there going to have to be a beam either at U.1 or U.2, one of the two?
You're talking about going
between 4 and 5.
If it spans,
how can there be no edge to the floor of the diaphragm?
It's an outdoor terrace there, correct?
Right.
Even so,
isn't there any sort of architecture along U.1 between 0.4 and 0.5? Isn't there a fascia?
Should we be showing the floor slab beyond what's being?
I'm saying you need to close out the diaphragm at that edge, if nothing else.
Okay.
It means there's a perimeter girder there.
Okay.
I'm going to look your image up. I'm struggling to remember what this looks like.
I'm sorry. Who are we looking at at the moment?
This is still me. This is
So you're looking for the floor condition in the plan? Is that it?
I'm going to show you.
Okay.
So this is the second floor. This is an outdoor terrace. So U1 and U2 are here, and then between 4 and 5.
But that's a terrace that has a slab with an edge.
Right.
Yeah, so there's steel
but
there.
On the next floor up, it's open here. So
okay, but then I think U2 is in.
Right.
Yeah. U2 has a beam.
It would be in U.2.
You guys, you've got to put cords and struts on the edges of floor diaphragms.
Yeah.
Stiffness and stability, okay?
Okay.
I mean, I can't, maybe there are some cases where you don't need to do that, but if you're, for the most part, you do.
Right. Okay. Yeah, that makes sense now that we had the reference to our floor plans. Alec, do you want to go to the next one of the?
I mean, if you really didn't want to see it, if you'd use an upturned beam in steel, it would kind of disappear into the slab depth.
Okay.
But
Yeah, and I'm looking at plate 14 in your slide deck from the last benchmark. You definitely have beams there. You've even drawn one in the rendered axonometric.
For along column line U2?
Yeah.
Okay, so that one needs to can find its way in.
And you'll have it at I think it's U. Yeah, see, you'll have it at U1 as well. I think up above.
This is the U2 column.
Yes, sir. Yes, sir.
Right.
And U1 is north of it.
double cantilevers are not easy to do. They're difficult to do.
Mm-hmm.
Okay.
Yeah, that's right. Optical illusion. I didn't even catch that you're not indicating a column at the hard corner underneath the upper two floors.
Mm-hmm.
The way that you will sometimes see them done is they literally take the wall that you're looking at, the two walls there, and they literally make those two walls into trusses.
Yeah.
That span back to the column in the adjoining bay to the right and to the left.
Okay.
That is not indicated necessarily. Sorry.
The other option is just to do the column at the corner all the way down through the retail space.
Right.
And let the beams that we're talking about you guys needing outrigger past the balcony on 1, 2, 3 and get picked up there.
So it just hangs out there.
Yeah.
I mean, you could do. I mean, that's an option, or again, you could do the truss configuration, but you'd have to show how that works, and you have to consider your windows and your window placements and balcony conditions to work within it.
Yeah.
Right.
Okay. I mean, it's gonna take some work to do that. It's may not be a quick solution yet.
I'm probably going to follow up then with a separate email conversation about how we can most practically simplify our upper right hand corner.
I think that's your goal.
So this is our proposed lateral bracing system. I know it's not ideal, but it's our theme for this was, well, because I know that they like to be a little bit more balanced than this is showing, but we're privileging our core locations with where the shear walls are, and then I pretty much just looked for anywhere that a window or any other type of I guess like a wet wall or a condition of a wall having something getting in the way of cross bracing, and the orange little strip right there was pretty much the only area I found as an opportunity.
But you have steel columns and beams up on the residential floor, right?
Right.
So you can make rigid connections.
Mm-hmm.
Is that enough for all of our?
I mean, if you're talking about having to address questions like, well, I don't want a diagonal brace here because obviously this interferes with the door fenestration, I'm saying the low impact solution is a diagonal brace. Now it's the most flexible, not that stiff, but you don't have that tall a building.
Right. Okay.
So I would start looking at saying, okay, rigid bays running along column line 5, along column line. It's hard to say. The other outer one, whatever is the most common outside wall, U1, U2. I don't know. Those is where I would start, and then I would say that I'd also go back to column line V and column line 3. Okay. So then I've got a rigid frame box on all my outers. That makes sense?
Yeah.
And then probably column line Z. That'll be the last one. So
you guys actually have more opportunities, right? You could actually put shear walls on the other side of the stairway along 01, along the other side of the elevator, the west wall of the elevator. I think you have demising walls that could actually act as shear walls.
If they're common, you can bury those in as well.
I'm not seeing a lot of them,
I
but
wasn't sure if we had. I think Alec and I had a conversation about it. Unfortunately, with our whole
well, you do at O2 between V and W, and that
I'm not sure.
and O3 between.
I don't think you could put a demising wall in at O2, Mark. I think they use
at least in the
between V and W, yes, but I don't
Yeah.
think it exists in
that's where I meant.
one. Right, but I guess I'm just okay. But
we'd have to revisit the program if we were going to do that.
Yeah, the only thing is it wouldn't work on the ground floor as it runs.
yeah, it's going through the
Yeah.
common room.
Yeah, that's true.
Right. But I'll note that as something that we can continue to look into as where.
You know, I'm looking at this, and I think that maybe W could be a
Yeah.
W could be a line.
Okay.
Yeah. And I think that's one that they've got. That's
Other
the
than
bottom
that-
wall of the elevator.
Other than that, though, you don't really have much except for O3
Yep.
between U and W. Those are the two that could be set up as some sort of a shear wall or diagonally braced system.
hmm
But you know, again, the rigid bays, again, at least obtrusive, and you can kind of put them anywhere.
Right.
So I would start with the boundary of the exterior as a possibility.
Okay. Okay. So here we have the wall section and then the partial elevation. They can, I think that the elevation I can probably colorize to give it a little bit more meaning and information. But
It looks like things are dropping off on you.
yeah, the column lines for some reason I could not get to return. But I'm looking into that. These are still continuously being developed outside of the PDFs as well. But
I want you to go to that lower left-hand side corner of the wall section because you and the prior team have the same issue.
Oh, you're talking about not showing the.
Well, you've got
the
that
beams.
projection of the boundary condition of the wall and the floor of the parking that extends beyond the structure, right?
Mm-hmm.
Does that make sense?
Right.
Something's got to happen in there.
Yeah, we have. There should be a beam, I think, showing beyond that carries the load over to the retaining wall.
Right. I'm also looking at the fact that the exterior wall is eccentric of the beam. Can you zoom in on that wall section to the left? Go to the lower left. Yeah, you've got about a, I don't know, 18-inch or 1 foot offset from beam to wall above. Do you see that?
Right. It's the same. I think it's the same issue with the angle of the section cut because our column grid is on a slight angle.
Okay, but I still would think there's a column that this beam's connecting to somewhere, and I just don't see a column line.
Right.
Okay.
Yeah, that should be.
Oh, okay. I see what you're saying.
Yeah, it looks like the beam's floating in space.
Yeah. Why would it be offset below but justified above?
Well, it's close to justified above, but it is in the same location. But I would still see.
I think it's just that the columns aren't showing up.
Yeah.
Yeah, I think that's my point. At the top of that drawing somewhere is I'm going to see a column bubble. And then I'm going to see some lines leading from that I section back to where the column is because it tells me it connects back to it.
Right.
Here's one more comment I'm going to make for everyone, not just you.
Okay.
Do not trust Revit. Okay. I mean, I think that we all know by now things that we see in Revit are not necessarily what we would expect we're going to see. For example, things that you don't cut through, let's say concrete, shows up with the concrete stipples that looks like you have cut through it, right?
Right.
So I know that it's easy to jump into Revit, show the section because that must be what really exists. And it may be, but it's not going to be in terms that Professor Farlow and I are going to understand in terms of normal section cuts. So as my suggestion is anticipate you will be going into Illustrator or Adobe or something, and you will be doctoring those wall sections.
Right.
You'll be taking out poche or solidity of material where it doesn't need to be there, and lines that don't seem to be there, you'll be adding back.
Okay.
Things like flashing are not going to show up.
Right.
Example.
I do have a question to that point. Do you have a preference on what, should we just poche at this scale the elements that we're cutting through in the overall wall section, or do you want that to be something that you mentioned would be doctored?
In the wall section, it ought to be the materials in their best description as they are, like that, as they exist.
Okay.
You know, it should be the best representation of the materials as if you were in the construction systems class.
Right. Okay.
Okay. And I would say that's the best suggestion I have when you're doing the details and wall sections and enlarged elevations. It's nice to color the enlarged elevations and to give some depth, let's say shade and shadow. But when I look at a wall section, I'm thinking I'm in the construction systems class.
Okay.
Plan cuts or details. Does that make sense?
Yes.
You know, again, I know these are not easy. We all get that, so don't worry about how many comments you get. It's not a
it's absolutely helpful. I think I don't really have any more to deliver on this slide unless there are any more comments to help out.
Well, probably be, you know, I'm sorry, could you zoom that again? Could you zoom the upper left? Is that what that was?
You want to zoom up here?
Yeah. Because I kept looking at looked like a blow-up detail of it, but it's not that drawing. It's another drawing, right?
The next sheet. I think the next
sheet. That's the blow-up.
The next drawing.
Yes.
Okay. So again, that's great. And remember what we said. Show some of these in color, right?
Yeah.
Lines. And I know that all I can tell you is from what I understand, the IBC 2015 codes and other codes are now starting to require that information showing up on drawings. And I know it's not going to show up in Revit, so you've got to go in Illustrator and show it. So what's the water barrier? It's largely going to be the exterior wall surface, and it's going to switch over to flashing sometimes, right?
Right.
What's the thermal barrier? Wherever the insulation is, right? That's your thermal barrier. Then it gets tricky. Your air barrier or moisture barrier are going to be somewhere behind that in the assembly, right? But they're not easy to call out, depending upon the construction. Okay.
Okay.
It is important, obviously, to know whether you have closed cell insulation or open cell. If you're showing a rain screen, and I know some of you have referred to it, you should be able to call out, you know, what that portion of the rain screen is for. Is it for a pressure differential that keeps water from pushing its way in, right? Does that make sense?
Yeah.
Rain screens, you need to know what they're there for. So, and there's also, I would say most of these sections we're seeing, there are some more framing members that are being shown. So there's probably light gauge steel studs at the top of this, right?
Mm-hmm.
It looks like it's hard to read. It might be there, but I can't really make it out. Does that make sense?
Yeah, so maybe a little bit of another pass at the line work. And
right. Remember, you have to create that whole frame out of light cold form steel, right?
Mm-hmm.
So it's got a top, it's got a bottom, and then it's got vertical studs in between, right?
Right.
You know, again, I'm looking at the roof condition.
Yeah.
And I'm not sure where the subroof is and what it is. Is it metal deck?
Oh, yeah, there should be detailing for the metal deck.
Right, wouldn't the metal deck be there somewhere? And then, of course, on top of that would be possibly your insulation. The insulation has to be, then on top of that would be some sort of a hardboard material, and then probably your roofing membrane, right? And then there's flashing that's going up to the parapet on the other side. The other side of the parapet's got to have an exterior finish material, right?
Right.
That makes sense?
Yeah.
Something's got to keep the water out on the backside. I mean, almost the elevation of that looks like there's brick or block in the distance. That wouldn't be brick or block, would it?
What are you showing there?
It's that's the turn for the roof, so that would just be the parapet beyond.
But what is the material is the question I think we're asking.
Oh, that would be the stair course. So I think we were just gonna do CMU for that.
Yeah, but I think, guys, what's going to happen is that let's call it EPDM just for, or maybe it's a TPO roof, but that roofing is going to lay flat on that horizontal assembly, correct? And then it's going to run up vertical surfaces like the stair core beyond, and it's going to run up the wall that you've cut in section in this drawing.
It's
and
like
as
a bathtub.
right, and as it runs as it runs up, it's going to run up a certain dimension. When you have a low parapet like this, some people would take that EPDM, that roof membrane, all the way up to the top of the parapet and do the flashing and counter flashing, that interlock system that happens there high. That's one approach, so that what you'd see beyond is nothing but the flashing and counter flashing and the roofing. You won't see much of the stair tower. You might.
I would say at this point, I'd probably take it out.
Yeah, that's my point. The other point maybe is that we're not really seeing the roofing condition here at all. I think Professor Farrow was talking about that, but you're going to have some sort of metal deck. You're going to have a base insulation layer. You're going to have some sort of additional insulation to promote the drainage, and you may even have a small cant that makes that transition from vertical to horizontal. At the end of it all, this parapet may actually need to get a little taller.
Okay. I have a question.
I mean, I don't know what kind of situation you have for the whole structure of the roof, but fiberglass, you can't walk on it, right?
Right.
So that's something you need to think about. Am I going to be able to walk on this?
Yeah. Well, where is the roof here? Is it the dark line just below the masonry block hatch?
Yes.
Yes.
I think.
Yeah. So why are we insulating there? Why are we insulating in the cavity of the roof?
Right. We don't even have the sub roof yet for the metal decking.
Yeah.
Going, and that's my problem. I don't have structure for that yet.
Yeah, and it doesn't look like the roof is sitting on the horizontal ledger beam there. So, and I guess if I could maybe give you some advice on this stuff, if we go back one sheet, Alec. Oh, you don't even do it there. Can you go back one more sheet? I thought that. Okay, so I'm gonna have to have a seance here and bring back like Casey's and Caitlin's section. Their sections had datums, floor lines with targets and vertical dimensions between each of the floors as we went up, so that we knew where the floor elevation was. We knew where the top of steel or top of structure was. And there was always a running string, an out to out, structure to structure, incremental. And as we continue to get closer to the wall section, we get more specific and more particular with those dimensions. Seems to me, guys, and I'm not just talking to you two, but it seems to me when you're going to embark on drawing a wall section, you start with the stuff you know. You all know where the walls are vertically. You all know where the floors are. So introduce that matrix of constancy within the drawing. Let those be the construction lines for your drawing, and in AutoCAD speak, freeze those layers so they never get stretched or moved or erased, right? And then build the wall vertically from there, right? That's the way I approach it. If you go to your next plate, right, I want to see that target right there where that steel is, and I want to see where the top of roof is. But you're kind of already embroidering the drawing with notes and leaders, right? And you've given up on top of parapet dimension, top of roof, top of steel. I think you need to have that stuff in play all the time.
So related to that, when you want to study a condition in architecture and the computer takes too long to do it, what do you use?
I'm not sure I know what you mean. When
you want to study a condition in architecture and you want to have drawings to view or visualize, that condition and the computer takes too long to do it, what is the next tool that you use?
Oh, a pencil.
And your tracing paper, right?
Yeah.
So my suggestion to you is to cut your time down. Look at that Revit drawing that kind of gives you the basic profile, and then sit down, as like Professor Farlow said, and says, this is what I know should be there, and work from that point as a series of studies and get the facts in the drawing developed the way you want it, right? Or the way it should be. Don't bother to try to do it on the in the computer. It may just not be that productive for you.
Right.
And trust me, the envelope specialist in the firm, that's what they're doing.
Mm-hmm.
They're going to start with that.
Okay, I did have a question too earlier about the conversation we were having about the continuous water barriers, air barriers, thermal. Would it be acceptable for those to just be shown diagrammatically and maybe not with like the, I guess the foresight of what specific material they are, or just where they are in the?
Well, I would say the code would ask you to indicate what they are. I mean,
okay.
Indicate where they are. That's what the code's asking. But of course, in an architectural working drawing, you'd have a note to indicate what it is, right?
Right.
And
I understand.
It's pretty imperative that the water barrier is known, because that's really your exterior envelope.
Right. Okay.
And the thermal barrier, if that's not known, well, then how do you know what your R value is?
Right.
And how do we know if this is a closed cell or open cell condition, right?
Right.
So, I mean, let me put it this way. If the air barrier and vapor barrier is not a product you're going to spend a lot of time looking up, right? That's okay. Please don't call it Tyvek. That's generally not considered a proper, by definition, a proper air barrier. House wraps are not.
Yeah.
Okay.
One other thing that the old school guys do with these things, Trevor and Alec and everyone
What
else.
is that?
That's a Sharpie, right? That's analog, right? So I've just said how important it is to think of the dimensional datums that regulate a drawing like this, and I want you to observe them and include those things with the utmost care and accuracy. But here's the secret: the stuff that's shown in section by us old guys, sometimes we will exaggerate their thickness.
Mm-hmm.
Right? So that we can show graphically a dashed line that us old guys have drawn by hand, but you might do in Revit or in CAD as the air barrier, so that we can see it as a graphical thing that exists within the wall section, and then we'll put the insulation just a skosh outside of that, so that you can see all of the elements in that sort of submarine sandwich, right? So right. It may not have it ultimately, and this is, I don't know how to say this very carefully, but ultimately the wall sections, the wall's thickness in a drawing like this may not actually be scalable. It'll be dimensionally close, but it may be exaggerated a little bit so that you can see and point to all of these ingredients, right? When you look at the wall sections that old guys drew, you will see that sort of license being taken, and you will learn that that it really does help, promote the clarity of those drawings when you start to think of where you can make this content more legible.
Right.
So, and the other thing I would say is that you're going to see plenty of examples of wall sections and details in those slide lectures I gave you. So please make use of them.
Yeah, please look at that stuff.
Right, and frankly, that's, you're going to find a lot of your answers are there.
Right.
So, and I'll just to let you know, if you're working in a firm, Professor Farlow, you're working there for Professor Farlow, and he wants you to develop ADA compliance for the units, right? What does he do? Well, he gives you maybe a manual to look at, or maybe he gives you a professional resource to look at, and he expects you to look at it before he comes back to your desk, and he expects you to understand to a degree what's there and to reconfigure those units for ADA compliance, right? It's this is the same conversation I'm having with you now. It's take a look at that material first, then come back and let's see where we are, okay? And a lot of things don't matter. So let me put it this way. If the wall section shows a wood stud and you have metal, pretty much everything in that section is still valid. Does that make sense?
Yeah, you're right.
Not a problem.
I do have a question too, since you brought up the point of hand drawings being an efficient way to get all this on paper. If they're at least like annotated to a degree that is understandable and clean enough, would that be an acceptable final presentation material if they're hand drawn?
Well, my suggestion in the ideal sense is you do the drawings first and we exchange them and we can look at them and then get them in the order that they need to be in, and then you just put them in AutoCAD or SketchUp or a graphic some sort of graphic software, right? Quickly.
Right. Okay.
But I mean, if push comes to shove, if you're going to do it, it should be a relatively carefully drawn sketch. In other words, not not kind of big. In other words, exactly what I'm looking at in front of me, but with squiggly lines.
Okay.
I don't know how else to say it.
Well, I asked that for more reasons than one too, because we had that earlier conversation about the overall narrative, or I guess the theme of our presentation being kind of like a playful, artistic, having that touch on it. So I just wanted to ask the question, but that does make sense.
Yeah, I think the question can be answered too. Does it make sense with the whole presentation, right? So if the whole presentation were approached that way, then I think you already know the answer. But if it's going to be a one-off drawing, then maybe that's not the right. That wouldn't be the same answer.
Right, and I would say let's say Professor Farlow brings in the building envelope expert at Hamilton Anderson to be on your review, it should be something that makes sense to him or her.
Yeah.
Okay.
Does that
Mark,
make sense?
Are you going to do that?
Don't answer that question. Sweat.
I thought you guys already knew who the critters were. I think maybe only Carl does then, if you guys don't know.
I'll gather some intel in the next couple of days. Okay, that all makes sense and is actually really helpful. So I think I'll get back to the reference material for this and probably include that in a separate email conversation as well. Alec, do you want to keep moving? I want to make sure that we have enough time.
Yeah, we do need to move on in time, so sorry.
So I guess to the earlier points, the main thing that I really wanted to just point to on this one was the pocketed beam detail on the right. That was the type of connection, or I guess the type of condition at the retaining wall that we were striving for. I don't know if you have any constructive criticism on that, on how it can line up.
So where's the floor line?
Is that if you're going to have some fairly large beams pocketing into that wall, which they seem to be on the bottom side of your sheet, I don't know north south offhand. But, you may have to thicken the wall like a pilaster to do that.
Okay.
You're going to be larger there.
I think you're right.
Really small, the real small bays up in that the top side of the sheet, maybe not.
Okay.
So Trevor, what's the wall above the floor line? What is that? Is that the retail storefront?
Yeah, that should change. That should change to curtain wall.
Yeah, something's got to stop there and be converted, right?
Right.
Yeah, so that slab actually has to sit on the foundation, not come to it. And then I'm a little concerned about what I'm looking at over here on the left, where the slab is interrupting the insulation plane and the drainage plane.
Yeah,
what is this? What is this shelf you're promoting here? Why isn't the wall slipping past all of the slab? Or why doesn't the slab cut? Why didn't you give that a shave?
It's a detailing error.
Okay.
Well, I understand why the wall has to be supported. Right?
Yeah, I can now, but
it could be supported with a shelf angle that comes up and reduces that thermal break problem.
Yeah.
Right.
Yeah, you want that insulation to have full continuity because that's also, that's also, I mean, insulating that slab is important.
Right. I mean, if we put that in the therm model, you know what happens there?
That's where it's leaking.
A break.
That's where the big thermal break is going to show up.
Right. So that's noted as well. And then
once again, I'm sorry, there is a lot of these things are covered in that slide lecture. Those slide lectures I sent along with you when I gave you the wall section lecture for the class. There's some online lectures in there that'll basically go through. One of them I think is called, problems or conditions with transitions, and it will identify a lot of these conditions we're talking about right now.
Okay.
So you guys have had construction systems, right?
Right.
Right. Okay. Andy, what was your reference book for that?
Buildings.
What was it? One was Ching, wasn't it? And then the other was
BCI.
Yeah, the building enclosure was BCI. That's right.
Yeah.
Okay.
That was my textbook, ladies and gentlemen, in 1976.
I guess.
Okay. Maybe time to crack that open again.
All right.
As well. Okay. Is that wrapping it up? Do we have some more?
Yeah. I mean, we haven't gotten to my portion yet at all. But,
Go ahead.
We can.
We
I mean,
can go through it.
Go ahead.
What was this? That was that's
so,
all right.
So I know it'll probably have the same comments as pretty much the last.
Okay.
Yeah. So my portion was the lighting systems, the reflected ceiling plans. So these last few are just the reflected ceiling plans divided in sprinkler system, lighting system, and HVAC.
I would want to see the whole image of the floor plan in like a half tone.
Okay.
So because I don't, you want me to look at sprinkler heads, right?
Yeah.
You understand what I'm getting at? I'm
Right.
lost in looking at everything else that's in a much darker tone, right?
Okay.
Yeah, really, the walls are way, way, way too dark. The column lines are way too dark. You wouldn't really want to show the poche. The content of this drawing are the light fixtures and the sprinklers.
Right. And it probably could be smaller if you need to combine it with other drawings. Okay.
Mm-hmm.
I mean, you'll convey the information. All the section cut things go away.
Mm-hmm.
Right.
Right.
The big section cuts too. So just simplify it. Make everything a half tone that's not essential. Color's not a bad thing to add. You saw what happened when the HVAC people added color. Right away, we could tell where things like duct runs were, right?
Mm-hmm.
So if it makes sense to do that, do that. No sprinklers in bathrooms, please. And closets.
Not in bathrooms?
No sprinklers in bathrooms. If you saw my earlier note, NFPA 13 does not require them, and I don't think closets as well.
Yeah, okay. I missed that. So it's okay. Thank you. And it's the reflected ceiling plan of the HVAC systems.
Do you have a central system for the whole building?
No.
Okay, so then
Central system only.
Aren't you guys using Magic Packs?
No, we have the VRF system with the units. So that's what these smaller, these little closets are. That it's the HVAC system packed into there, and then there's an ERV room for an ERV as well.
Hello?
Yeah.
Did we lose you for a second?
I just got dropped.
No, you're here.
I think we're good.
Did you?
I'm back on. I just lost you for about 30 seconds.
Yeah, we have the VRF system for each individual unit, and then a central system for the public spaces, the corridors.
So I think basically you could just show us the common spaces in a plan like this, and then do a blow up of the unit like some others have done today.
Okay, because
not the whole building. Yeah.
Right. We did that in the previous
Okay.
module, but I wasn't sure if that's what you wanted or not. So.
Well, I do need to see the whole floor, but I'm just saying for the units, you can just do a blow up of, I don't know, 1 or 2 sample units and you're done. Okay.
Yeah. So we did the whole floor.
Yeah.
And then the blow ups of the units. This was our previous.
Yeah. Then I think you were done with it. I mean, you're basically done with it, right?
Oh, okay.
Okay.
And then the last one was just the lighting.
Okay. Again, I would think that you would probably just do lighting for the common areas or something in this.
Right, and then blow up the.
Add the do it at the unit plan scale for the units, right?
Okay.
Same thing, make everything that's not important wash out like a halftone.
Yeah.
That are important, make it stand out. Can be smaller, probably smaller.
Okay.
So a lot of the lighting in the hallways actually was not shown, so that's kind of what you need.
Yeah, well, I did made a choice to do sconce lighting in the hallways along the walls. It's probably harder to see.
Yeah,
this is the side.
Okay.
Yeah, so that's when you exaggerate them by color or scale. Even if you're not drawing the fixture at the actual size, you want to make sure that we see it.
And if you have a little,
that's the focus of this drawing.
And if you have a cut image of the fixture, you could show the little cut. Maybe you have a picture that shows you what the image, what that unit would be like in a space like yours, a photo.
Okay.
Add that, so we kind of know the character of it.
Right.
All right. I'm sorry. Anything else?
No, that's all.
Okay. All right. All right. I think we can wrap up and move on to Stefan and John then. Thank you, guys.
Thank you.
Who do we need to go to?
John and Stefan.
Who's going to present, John or Stefan?
I think they're in the same room, right, guys?
Yeah.
I'll keep
So I'm screen sharing, right?
Yeah.
So John?
Yep.
Okay. You're on.
Okay. So
I'll take over so for our structural plan, we kept the same stuff that we had from benchmark 3, where we had the code analysis. We included the changes that were still under the code required or the code required heights for heavy timber. Okay. I think the height is 60. We're at 58. We've changed the numbers to reflect how much area is actually allowable as per our area and building type.
Okay.
So transitioning, and I've included the information that we sent emails back and forth on.
Okay.
Moving on to the next page, it's just kind of breaking up, showing that we're using the podium construction, and we have heavy timber above.
Okay. I would say probably the thing I would say about that image is that it can be a lot smaller.
Okay. Yeah.
Maybe condense it with the images up above, and probably label what the construction material is for type 4 and type 1. Like this is concrete, this is CLT, right?
And combustible, non-combustible.
Right. Right. But I think it's a useful diagram, but I would make it smaller and I'd put it on the first page.
Yeah, and it is graphically a little clunky.
Yeah,
right?
we're gonna.
So it's not as elegant as some of your other drawings, but I love the drawing. Right.
Yeah. Well, we're gonna clean it up to show you where we're using the stick frame as the infill panels for our exterior wall facade.
Okay.
So it's still a work in progress.
Okay.
The next page is more kind of details in terms of how we chose our CLT flooring numbers and some of the span tables.
Okay.
Transitioning further on, next page.
Can I make a suggestion? Sorry.
Yeah.
If you use font on a slide and it's less than 16 point, most people cannot read it.
Okay.
My other quick suggestion would be always put a clear header somewhere, on the sheet that says this is what I'm you know, like you did there, structural system planning, right? But
Mhm.
really, that's the, you know, that's the building code, right?
Yeah.
So the word code assessment underneath it, that needs to be like, you know, twice as large or 3 times as large, right?
Okay.
Code assessment, and what code was it, right?
Okay.
IBC version something, right? Okay. And so just kind of keep track with your labeling.
Yeah. Well, once we combine both our studio and
Oh,
lab,
I understand. I understand.
we'll revise it. Kind of transitioning next page. So now we're just showing our foundation layout. So pad footings underneath our stairwells, mat footing or pad footings underneath the columns, and the trench footing underneath the foundation, the perimeter wall. Kind of transitioning to the next page.
And column line, sorry, back up. And we have got a clear indication that column line F does not go through my stairs, and there's no column line going through the elevator shaft of the upper stairs, right?
Yes, correct. That's a.
There's no beam going.
There's no beam going through it.
No
So,
beam either. But I will tell you, looking at it, I wouldn't know that.
it's actually picked up on the next page.
Okay.
So when we go into the next page, we're showing
Okay.
So we could
Right.
show like dotted lines to show that there's beams above.
Well, right, or there's a pilaster thickened wall that's going to carry something there on the one side,
Okay.
right?
I mean, this is the foundation plan, right?
foundation. Yeah, we're just showing where the footings are because the next
Okay.
one is going to pick up. Our,
Oh, okay, so this is not a cut. This
Yeah, this is this. So this is the. Is this the
this
framing
is
plan?
the cut.
and yes,
Okay.
So you see my point, though.
I do. Yes.
Okay.
We'll also create an ISO, or at least an isometric, so just to kind of give it a better perspective of
Yeah, that would help.
3D, and then have the plan blown up to have all the detail that we need with the dimensions and everything.
Okay. Okay.
So the next page is
Concrete transfer beams. I don't remember those before. Sorry. I guess you had to have them in, huh?
yeah, because we're picking up that wall on that or do we have them? Yeah, we had them before.
These guys here.
Yeah,
Okay.
they're picking up the exterior wall that's coming right there.
Oh, so it's just an exterior wall?
Well, yeah, but we have columns on top of it, right? Right. Yeah, so
Yeah.
we'll need to pick up that load somehow.
Yeah.
Yeah. Yeah. And that's also going to be in the parking. No, that's above the parking deck, right?
That, yeah,
So is that transfer beam going to work its way into the parking deck or no?
Well, it's gonna clear the parking.
yeah, we're gonna have to have it because I think we originally anticipated that we had a little bit more space, so we could
Right.
into the deck.
Okay.
We need like
No, we need 7 feet,
7.
7'2" for a car. Or,
That's the minimum for like a van.
yeah,
Yeah.
So, and I think we
These
had,
are hard to size, but they're obviously going to be more substantial.
I think we had at least 1.5 to 2 feet of play in that area.
Okay.
Kind of the same thing kind of gets picked up with the ground level,
Right.
and then I guess we could move on to the next pages.
No, let's go. Can you zoom on to the stairway in the lower right?
Sure.
Okay. So when I look at the stairway at the middle on the left wall, I see what looks like a pilaster that's picking up the beam along F, right?
Yes.
But when I look on the right-hand side of the kind of the wall of the stairs, I don't see the same kind of pilaster condition. So what can you tell me is happening?
It's exactly the same thing. We'll pick that up on
Right. You see my problem, right?
yes.
Okay.
You know, you guys are showing these structural specs in red. Maybe you replace the column footprint with the red ink. You know, that might help make the stuff jump a little bit more.
Okay, bring back what we did for benchmark.
Yeah, I thought that was really spot on back then.
And anything that's not structural, again, could be a halftone. Right?
Yeah, that can all vanish. that can all go
Let it
away.
fade out, right?
Okay.
That's really not important.
Okay.
And then, so, you know, again, that upper stairs, right, and elevator,
Same
Okay.
thing.
The same thing.
my comment's the same. It's like I'm looking for that pilaster again, so I'm not seeing a beam running through my elevator.
Okay.
Okay.
Mhm.
All right, so we'll pick that up and we'll do the.
I mean, you know, Mark brings in a guest reviewer, and if they're looking, they're gonna be asking that same question unless they get a clue that it's not a problem, right?
Okay. Yeah, we'll pick up the columns and
Okay.
the red, make it really pop against everything else. I think that should clarify.
And some of the columns look like they're different sizes. Just we're curious.
Exterior column.
Like column along D6 looks huge, but
Yeah, the six column line and the 1 column line.
is there a reason? Is there a reason for column sizes changing? Are they being finished with a finished material, or?
I think when we were drawing it, when we used the block, it popped in a little bit bigger. Because in the drawings, they should be all the same.
Well, I'm saying the column variation size is almost twice as much.
Yeah.
D6 and 3C are, I mean, they're significantly different, right?
Yeah.
Okay.
If anything, the interior would be bigger. And the exterior would be smaller.
Well, usually exterior is not that large because the tributary area is smaller, but you're picking up the exterior wall, right?
Yeah.
Oh, that's, yeah.
That could add weight.
It's timber, yeah.
Yeah.
They just don't seem to be commensurate and consistent.
No, I think it's just a drawing error.
Okay, keep going.
Next page. Yeah, next page. So here we're showing the 9-ply CLT deck.
Okay.
The glue lamp where we need it above the windows. And can you zoom in a little bit?
So the 9-ply CLT deck then, obviously there's got to be a frame out condition occurring again at stairs and elevators, right?
Okay.
So is that a beam situation again? That's going to be the edge condition for those frame outs?
Yeah. We were looking at it, it was more because the concrete shaft is going to be structural. We saw some details where they had an angle connection towards it. So
like a ledger angle.
Like a shelf angle or a ledger?
Okay, so can you zoom out for a moment?
We kind of pick it up in our typical details later on.
Okay, so if zoom out a little bit more, sorry, but not too much. Okay, so between 3.1 and 4.1 and C1 and C2, almost all of that except for a little bit of space is really a void, right?
Pretty much, yeah.
Yeah.
Yeah, it's all concrete.
Right. I mean, there's just the little area outside the elevator that's got a floor.
Yeah.
And I'm assuming that that's a drop-in prefabricated stairs, and that's why, you know, it just matches up with the floor and goes in, right?
Correct. Yes.
Yeah.
Okay. So that's kind of what I'm getting at. It there should be some clarity as to how that CLT is going to be bordered or bounded, so that I get these chases, right?
Okay. So okay.
Same thing with the stairs, lower right, and looks like an HVAC chase too, right?
Okay, so
yeah. And a garbage chute.
Yeah, and the garbage chute and the mechanical shafts. So we'll just add the ledgers that we need to. Or
yeah, I think it's kind of like, if you imagine, you know, how you frame. I mean, I know CLT is different. I get that, but even in concrete, when you're framing out openings, there's usually a thickened border condition.
Okay.
A peripheral element around it, right?
Okay, I guess we could. Yeah, we'll pick that up.
And also in the floor, actually in the exercise room, you have a stairs in there, right?
I think that's like a drop-in type of
drop-in stair, but what's it called? For the first floor, the one that we're looking at right now, it should be a deck, and that's going to be just a mezzanine on the next floor up.
Okay, but just make sure everybody understands there's a 2-story void in there, right?
Yeah, correct.
Okay. Go ahead.
So, and then moving on to the roof, now it's a 3-ply CLT roof. We're just kind of showing the spanning conditions and how the layout would work.
Okay, so that's the roof level. That's why there's no columns showing up, right?
Yes, that's correct.
Okay.
And then the fine lines is the roof below.
Okay.
We just wanted to put everything on one plan just to make it a little bit easier.
Okay.
And then so now we're just picking up some of the details, so the connection details between the floors and the CLT mass wall or mass timber walls, and the concrete and the CLT and how we get connected together.
Are those rigid connections?
We're kind of technically they are fastened from top and bottom, and they're connected in all three. They're secured in 3 axes.
The argument that we were talking about earlier was that because we have shear walls in locations, we don't actually need a rigid connection everywhere.
Right.
Yeah.
That's our understanding. We have shear walls and rigid diaphragm floors.
Right. You wouldn't need to have rigid connections everywhere, but they look like they're rigid. I'm just curious, because my ignorance, the CLT, it looks like it's built like platform framing, where every floor only spans one level, or the column or the load-bearing wall only spans one level. Is that correct?
That's correct, yes.
Yeah.
Yeah, in that case, I will say, though, that adding the angles that you have there to suggest rigidity and stiffness is going to be good for lateral loads.
Okay.
Okay.
Like, so, for example, platform framing, type 5 construction, residential, because of that lack of continuity of walls and the lack of continuity of columns, it's not that good for lateral load resistance. So your L channels will help add some continuity and stiffness.
Okay.
Okay. So we would consider the L channels, L brackets,
That's the
rigid
difference.
connections.
Yeah.
I'm not exactly sure. You might want to see how they're classified, but they certainly look like they're adding stiffness.
Okay.
Maybe contact Sire or whoever's doing the. It's not Sire, but whoever is promoting this product.
Yeah, I'm sure there's
strategy.
plenty of literature out on these today.
Okay.
No.
I'm wondering, guys. I'm sort of looking at this wall to CLT floor connection, which is spelled wrong, by the way. Connection is spelled wrong, but more importantly, like I guess for you guys, the floor and the walls and the ceilings are the finished materials, and I say that because the case studies you showed sort of make it clear that this system is attractive, not only because it's like this authentic structural system that comes from the forest, right? But it is the finished sort of quality, right, of these spaces. So I want to make sure that that's what you're going for.
Yeah, we were kind of planning to expose the ceiling for sure.
Yeah.
Not expose all the walls because it would be just too much wood.
Yeah.
So we're kind of working on a detail right now where it's going to be we're going to have sections of drywall that's going to kind of break up the.
So yeah, but as like a revetment or a veneer, right? As a
exactly, yeah.
An application, and then so like electrical outlets, convenience outlets, those have to have exposed conduit, exposed
on the ceilings.
Yes.
Conduit and then surface mount.
And then we were thinking of
I don't have a problem with that, but I just want to make sure that that you understand
what do they do with the
implication of that.
What do they do with the conduit? Do they bury it under a baseboard cover plate?
Well, for the detail that we drew up, we wanted to do a furring strip that would allow us to run the conduit in the wall, and so we would have the electrical where we kind of really require it. So on one of our plans, I think we specifically put our kitchen and all the, let's say, the utility spaces on certain walls where we could hide those with the drywall and expose the other walls that we really don't need the electrical.
My other thought would be you just have a kind of a heavy duty baseboard.
Okay.
Right? That's thick, and that's kind of where that electrical is going to run. So that heavy duty baseboard covers those L channels that you've got on the wall.
Okay.
Right. And then you don't have to do anything to the wall.
Those L channels are brackets, though. They're not continuous, are they?
That's correct. Yes, they're only brackets.
But they unless there's a wall or something abutting them, they would be seen.
Exposed, yeah. That's why we were kind of we had last. I think we had the last.
I mean, I'm just suggesting a heavy duty baseboard would allow you to basically have your electric run concealed.
Oh, yeah, you already get this drawn
with the wall.
Okay, so we should.
Yeah, so those metal brackets are going to show up in my space, though.
Yeah, and I think that's part of the charm, right? The real surface material is the wood, the wall is the wood, ceiling is the wood. The brackets are there, they're
They're
evident.
They're going to be under the rug.
What if we recess the brackets? with the system, then we could kind of recess the brackets a little bit and then have the brackets kind of
Like
You think you could carve out of the top lamination to drop it down?
I saw some details, column details, where you could actually recess the pocket, let's say the mount for either the shoe for the column or anything is actually recessed in, so it's
flush.
And we could do the same thing over here.
Yeah. Okay. Yeah. Again, I think these are the good considerations you need to give if you're talking about exposing that.
Okay. So this is just kind of showing us where the CLT and how we're using the ordinary frame for around the windows, just to kind of really simply just demonstrate that.
Okay.
So these walls aren't load bearing.
No, it's
These
all
are carrying like wind load to the.
That's just
well, the facade, right?
Yeah.
And the insulation kind of gives us the ability to insulate the cavity if we need to. Okay.
This is
a general note of how sustainable the project is.
Yeah.
And
just a summary of the structural. I'm sure we touched on every point here.
Did you write that, or did you find that somewhere in a publication?
That we wrote.
Okay. But it should be sourced.
That's all us.
Sorry?
All us.
Okay.
But yeah, we're not going to read it now, unless you want us to read
No,
it.
no. Just keep going. I'm just checking on attributions and authorship.
Okay.
So this is getting into our HVAC and lighting section. So this first plan shows zoning of the main floor. So just breaking up the main corridor, lobby space in blue, retail space, mechanical and like tertiary support spaces are in red, because we're thinking we don't want to mix that air with, public air. If it's like a mechanical room, or especially like the trash recycling room, we'd want on a separate zone. Plus there would be like different set points for these different zones. One point for the lobby and corridor public area in light blue, we've got a glass wall and glass door separating the north and south areas in light blue. So that's in a way so that we can break up that zone into two different areas, the north facing, south facing, as the south facing will get more sunlight in the summer. And
Are vestibules typically conditioned?
I want to say.
I don't think so.
I'm not sure they are.
So,
no, they're not.
So I think they're probably just white or something, right? Not conditioned. I can't think of any cases I've seen where they've ever been conditioned. So.
Okay.
HVAC. HVAC.
All right. So
okay. And then
I'll write this down and then you continue talking.
Okay. And then just this is just showing the zone. So like the exercise room.
Okay.
A different zone. And then we have the write up there, just explaining each zone. I think I can keep going here.
Okay.
Questions about that?
Well, and I think that what you're doing with the narrative portion is exactly right. You need to describe, what the system is about. I would add some headers to the various sections of it.
Okay.
And maybe because right now it's just one running stream, but I'm not knowing what the subtopics are, right?
Yeah. Okay. Yeah, we can.
Probably the first thing is just to say, what is the system type?
Okay.
What are the major components and where are they located?
Yeah.
I chose this because.
Yeah. This is the list that.
Okay.
This is as you were asking questions on the lab questionnaire sheet. So
okay.
But for our final presentation, we should.
Okay.
It'll be a lot cleaner.
Yeah.
Okay.
Okay. And then this is just continuing with the zones on the typical upper floors.
Right.
Residential area is its own zone because we're using the Magic Pack system. And then we got public zone, and then in white is obviously the elevator stair zone. That's got to be a separate zone because there's higher pressure in those areas.
The vertical penetration.
Yeah. Yeah.
And also like the laundry shaft and the mechanical shaft, that wouldn't be conditioned, would it?
No, it wouldn't, would it?
I just think it's a white zone, just like your stairs, right?
So everything, all of our vertical penetration will be in white.
Yeah, that's what I would think. If it's not a space per se.
Okay. Well, the stairs. Oh, elevator isn't conditioned either. Then, yeah, the stairs are conditioned, so I got to change that. Right. Well, it needs HVAC because it has to be a higher pressure. Oh, wait, is the elevator?
It's a pressurized shaft.
A pressurized shaft, yeah.
And yeah, so just the stairs. Okay.
No, but I think your HVAC and your mechanical shaft is just white. I don't think it's not tempered. It's not a zone.
Yeah.
No thermostats are going to it.
Okay. I didn't think of that. So I got to change that. I got to update all that.
All right. Penetration white.
Okay.
Zones.
Think about it this way. If you call it a zone, it's probably got some thermostat control associated with it, right?
Yeah.
Okay.
If it doesn't, it shouldn't be a zone.
Okay.
Okay. All right. Moving on. We've got, this is our typical upper floor reflected ceiling plan.
Okay.
So the HVAC we're showing here is the same thing I showed on the last lab.
Okay.
We're showing the VRF, variable refrigerant flow, VRF, running to the different air handling units. That's the same thing we've been talking about. And then we've just added lighting in the corridor.
Okay.
As well as sprinkler.
Corridor lighting spacing looks pretty large, though.
It is.
Yeah.
I mean, I would really wonder that you're going to get adequate light in the corridor with that spacing.
I was thinking about that.
You could probably double it and be okay.
I think that's what I would be thinking about too.
I thought maybe because the ones I'm showing here, I'm showing as wall mounted. So they're like wall sconces basically. But if we were to have those and then as well as maybe lights in the ceiling, because I think we're doing a drop ceiling in the corridor.
Yeah, sure. But I just say right now, my gut reaction is I think the spacing of those is too far apart to really get a decent safe distribution of light. So, and again, I mean, if you want to have a product cut or something, then you can tell us what that is, right?
Okay.
We should do that, yeah.
And of course, is it a low energy fixture?
In the notes, I was just saying like all LEDs.
Okay, but all right,
we should have,
call it out. I mean, I would say the same thing in that one space. That's is it gym or is it the laundry? There's like one fixture there.
Yeah, we'll detail that out a little bit more.
Yeah, I know there's got to be more than that.
Yeah.
Probably the sprinkler heads. I mean, they're getting kind of confusing, but I would certainly make them smaller and maybe a somewhat different symbol.
I think on the final we'll make the floor plan bigger.
Yeah,
okay.
And then
how about we just remove it, move it off, and
I'm also wondering if you've got enough sprinkler heads, because again, there seems like most of the distances I've seen for these are spaced at like 6 to 8 feet apart.
Okay, we'll do a more detailed reflected ceiling plan to show that.
Okay, I just think there's not enough density of some of these elements that you really would need. So.
Okay. We do have like I found a website that ran us through a quick like estimating for sizing.
Good.
Corridor, and then there was a cut sheet for the VRF that said with that sizing of 30 tons, we would need maybe 3 of their big units. So,
okay, great.
So then on the roof plan, we kind of connected that to where we would.
Right, and definitely include that and use that as a reference.
Yeah. Okay. Okay, then going forward, this is our typical suite again. Same thing we were showing before, except adding again the lights and the fire sprinklers. Basically, I was just trying to get like one sprinkler next to the kitchen, and then one for each of the other rooms.
Again, I don't think sprinklers are needed in the restroom, though.
No. Okay.
No, my understanding is they're not.
Okay. Yeah, we gotta do a study on that. Was there anything else I should talk about on this? Lights. Oh, and we talked about this before. All exposed conduit and then flush mount, or sorry, not flush mount. Ceiling mounted.
Yeah. Well, since we have
surface mounted.
Surface mounted.
Yeah. So since we have that everything kind of on one side. We're going to do like a drop down bulkhead to hide as much of our ductwork as possible, so we could leave the ceiling in the living room and the kitchen kind of exposed, and maybe run a perimeter bulkhead.
So my question would be related to that, although that might not make sense. I don't know yet. Would it make sense to incorporate some of your lighting into that bulkhead?
I think so. Yeah.
Yeah, like
Clean that up.
Yeah.
Yeah.
Okay.
You know, I don't mean to quarrel with you guys, because I think you have a lot, you know, that you've sort of thought through here, but I'm still intrigued with this structural system as a finish system, and I'm wondering if you have any appetite to consider exposed ductwork, exposed HVAC, exposed sprinklers.
Yeah, we were.
Got to be appearance grade, though, doesn't it?
Yeah, it has to be, you know, oval or circular. It's, you know, it's more expensive, but these units are very tight. They're very tightly organized. They work off a centrally located magic pack. There's not a lot of ductwork run, and as it runs to the limits, right, to the bathroom, for example, in the end of the living room, that ductwork could get smaller.
Yeah.
Okay.
Yeah.
I'm just wondering if you sort of,
yeah,
I mean, did you think of it, or did you just sort of default to concealing it in a bulkhead?
We were thinking.
I think there's some value in, you know, testing that limit.
I think it adds to kind of like this contemporary, I want to say like deconstructed with like the shown CLT. Okay. So in certain areas we were thinking for sure exposed conduit and exposed mechanical.
So related to that would be my question, you know, have you thought maybe about a perforated wood panel to make the bulkhead out of?
Yeah, you could do that.
And then I don't have a diffuser anywhere because the diffuser is always hidden behind the perforation.
But you're still going to have exposed stuff, because if you're going to have sprinklers, you're going to have piping linking them, so they're going to be in the room. They're not going to go drill from the floor above.
I think that would look cool though, with like cast iron sprinkler.
Yeah.
Run.
Yeah. I mean, I think it, you know, if you ever read about like Allison and Peter Smithson, right, that talked about kind of truthfulness and honesty, you know, truthfulness in the detail. They revealed everything in the toilet rooms and the bathrooms, the washrooms, mechanical systems. If you look at the work later in the 1960s of people like Hugh Hardy, Holtzman and Pfeiffer, and Jim Sterling, even later still, their work celebrated the gritty realities, right, of those systems. And your project is kind of like rubbing up against, you know, structural honesty as something that has strength and integrity, but like aesthetic virtue as well. So thinking about like exposing these things could extend that language.
Sure, and I think today residential people, designers, as the term may be, will call it steampunk.
Yeah, I think there's a phrase for it, right?
I think there is a phrase for it today. I think you're right.
So I guess I'm just asking you, before we like marry ourselves to soffits or suspended ceilings in the corridor, if there's any appetite for you to say, let's just like sit down, have a cup of tea, and then go through this once more before we commit to it.
I think we were thinking about that for the suites. I think one thing for the corridor is that we thought of putting the drop ceiling in the corridor, especially because we have the air handling units that have to be above the ceiling. So unless we have some sort of, like you said, like perforated build out that we could work into it.
Yeah, but we could do like a drop ceiling that's not fully, it's not like really a drop ceiling, it's just suspended, and we're just hiding the panels with like something that's below it.
Yeah.
And then everything else is exposed.
Yeah, that'd be fun.
Or do the perforated suspended ceiling or cloud at a condition where you need to hide it.
Right.
Not necessarily
not for the rest of it.
Yeah.
Right?
Yeah.
Because we only,
again, you know, there's something really nice about honesty.
Yeah.
Have you seen those little lights? And I don't know if they're HEDs or not, but you see them. I've seen them sometimes in residences, but they're really small and they come down from the ceiling on a small wire.
What are they?
Like the string lights?
Yeah, little string lights, but I don't know if the word is string light, but they're like a little high intensity HED, and they come down on a small string. They usually suspend from a ceiling or suspended from above. Sometimes you see them in residences, but more often you'll see them in like a retail store.
You think it's a glass bulb around it?
No, what I'm getting at is you already have the piping up there for the sprinkler system, right?
Yeah.
I don't know if there's a way that maybe that could also be a line of support for those sorts of lights, perhaps coming down in space.
Yeah.
Okay.
That's
Right. Like actually thinking of unifying those disciplines into one like cohesive like statement.
That's phenomenal.
So that means the sprinkler layout and piping is now part of the electrical layout and
your lighting layout
starting to work together, right? And I think that, we talk a lot about systems integration, and I think one of the attributes of that tends to be, how can I use one system or element to do something else?
Yeah. Brilliant. So I guess I'd like to have you guys think about that before you do one more dive off the board.
Okay.
So
this is the one that we should have started with, I guess. This is showing the VRF.
Overview.
Yeah, this is the overview of the.
Yeah, and I think that, and then your information about sizing. Those two would be the way I would lead it off.
Okay.
Yeah, these should be together.
Okay.
Yeah. We just have. I found a system that Honeywell Ascent system has got like a total overall remote monitoring the HVAC and setting different.
Is there a dehumidifier in this package?
The only consideration to humidification was the ERV. My understanding is ERVs can help in the dehumidification.
I'm not sure they all have dehumidifiers built in. If not, you're going to have to add one.
Okay.
But because it's Michigan,
you got to have one.
We're classified as humid, cool.
Okay.
Humidification will help reduce your HVAC load.
So that would be in the air handling unit.
If not in the air handling unit, it might be a separate element.
Okay.
It's coming. It's only gonna condition the interior air. Remember, it's not the exhaust air.
Okay.
Okay. Yeah, I can look into that for sure. We got that right.
Yeah, I got that note.
But it may be a box that's somehow again behind that. I don't know. Let's say the drop soffit thing.
Yeah.
Okay.
Okay. This is our alternate energy. I went to the website there for the photovoltaics. 200,000 kilowatt hours per year, which I think sounds so. So that says we'll be offsetting $20,000 in annual energy value.
And what percentage of your total load is that, or do you know yet?
I forget now. I think I had a ballpark.
Okay. Have you run the Insight 360 yet?
Not on the model as it stands now.
Okay, you guys. I think that would obviously be your next step, right?
Yeah.
Okay. We're going with that for the extra point.
Yeah, for the extra credit.
Okay, and again, Professor Farlow, please watch your spelling.
Here's that.
You've got some spell checking to do, okay?
Yeah, okay.
Okay.
Doesn't have spell check.
I would say that this gets combined with your Insight 360.
Okay.
That point.
The stuff, yeah, for sure. And then a plumbing thing too, which I've never done a plumbing before, but it says we can, with roof and site water retention, we can gather close to 400,000 gallons a year.
Can you scroll down? Because is that the next one, the water one?
That was this one. This is the total rate.
Okay, all right.
But it's
where is the cistern located for your project?
In the parking garage underneath the ramp. Actually, it shows it on the next slide here. So this slide is kind of confusing in that we've got our first floor plan with our mechanical rooms down in the bottom right.
Yeah.
And I wanted to tie in the site retention. So I've got a partial site plan sort of superimposed here where the courtyard.
Yeah, I see that.
And then I've got a superimposed parking lot.
How would you size your cistern? Would it be based on consumption per per week or consumption per month versus rainfall per week or rainfall per month. Does that make sense?
Yeah,
Okay.
it makes
'Cause
sense.
as you're filling up, you're also draining down, right?
Right.
So
'Cause you don't want this cistern to be larger than it needs to be because it's probably be huge.
Okay.
And also that it probably has its own foundation, right? It's like a huge mechanical unit. I
Okay.
mean, just imagine the weight of that, right? So it's probably got its own foundation. Does that make sense?
For a building this large, it's probably going to be like 3 or 4 cars. Think of like 3 or 4 vans. You know,
mm.
Yeah, like,
So
probably 3.
could I just divide this gallons per
like
year?
6 tons or something is what this is going to weigh.
I think if you plan for like a 100-year event,
Well, like I say, you remember
More.
it's not just collection, but it's also the fact that as you collect, you also use. You're using it, right?
That's what I mean. So this gallon per year, 400,000, we could divide that by 12 maybe.
Well, yeah, I'm not sure, but what I'm getting at, even if you divide it by 12, you're looking at the fact that you're just collecting.
Yeah.
What I'm saying to you is your building occupants are using, right?
Yeah.
Toilet flushing and whatever it's going to be used for, right?
Yeah.
Yeah.
So you can take that off of, right? Does that make sense?
Okay.
Yeah.
yeah, you're always borrowing from it.
Right, you're always taking off, right?
Yeah.
I mean, you know, what is the average per gallon consumption of a human in the United States? I don't remember.
That guy right here.
How many gallons a day, right?
Of course he has it.
25 gallons of gray water per day.
How many?
25 to 45 gallons of gray water per day per person.
Wow.
Oh, so hold on here. I got the calculation here. Taking the average of 35 gallons a day, I took the average 25, 45. And then I just averaged out 11 studio apartments times 1 person, 32 single apartments times 1 person, then 7 double apartments times 2 people. We've got close to 2,000 gallons per day. So then I times that by 365. That gave us 730,000 gallons a year.
That's twice your collection then.
That's twice the collection. So we're offsetting half our water, gray water.
Yeah.
So
I
that's
don't, you know,
cool.
again, I don't know what goes into the gray water definition, 25 to 45. I'm just thinking that seems high to me, but
I think, yeah, like washer machine, shower.
Yeah.
I don't know.
well, but back up a minute.
Mhm.
I don't shower with gray water. Right? You understand what I'm getting at?
Yeah, it's the water is not used for
Not just
everything.
water.
Yeah.
In that sense, I would say it is what would be the gray water percentage of that true gray water percentage. And my argument is, other than toilet flushing water, I don't know what it is.
Yeah.
Yeah.
I see.
Everything else I encounter will be potable.
Yeah, all of it needs to be potable except toilet flushing.
Okay.
Okay.
So yeah.
So you might. What I'm getting at is that number might be smaller,
Mhm.
and your percentage might be much larger than you think.
We have to nail that down.
But anyway, good work on that. I'm sorry. Keep going.
Okay. So then this is just showing like the general water runs, and then fresh water into the mechanical room where we would have a boiler system. And then, also, I think the apartments would want to have what's called domestic hot water heat recovery system. So like hot water from showers would go
Right.
preheat water going into the boiler.
Okay, you're gonna find a unit that does that.
Oh, yeah, we're gonna have to.
Okay, I mean, because you have to configure that. There is something that does that.
Okay.
I have seen them, but I can't tell you how well they work, but I've seen them.
Okay. So then moving forward, this is our roof plan, showing where the 3 rooftop units would go, and then just showing rainwater leaders, rainwater roof drains on each.
It does look like some of your roof areas are really large for a roof drain.
Yeah, especially that one.
That's
Yeah,
center
the big purple one is probably the most.
You have a feeling that could be cut down into 3 sections.
At least 2.
Okay.
Yeah, minimum of 2. And then, as Professor Farlow's pointed out, what's the overflow?
That would have to be some sort of scupper.
So there's not just 1 drain per section, there's 2.
Yeah. Okay.
Okay. Yeah, we'll have to add that and add the notes for that.
Yeah. Yes. Notes.
So if we have an overflow scupper, can that just like shoot off the side of the building?
Yes.
I guess so, but you'll never see it in your cistern.
Yeah, that's correct. You'll see it located high and sometimes low. If it's located low, you've got vertical conduit pipe running from the point of intake all the way to the point of discharge, which has a cost impact.
Unless. Okay.
Okay.
Yeah, we could figure. Yeah, we could figure out a way to use that water still.
I mean, like if it's shooting off the roof, it's still going to hit the site below. Which if we have.
Yep.
Yeah, if you've got all that kind of plumbing going on down there that can redivert it.
Yeah.
Right.
Okay.
Okay, go ahead.
Okay.
I think the last little bit is just we're showing the wall sections. So essentially, that we had. You want to just zoom in on one of them?
Yeah.
So
Yes, please.
we have the parapet detail, and then
Can you zoom in more?
You guys need rock wool on the outer wall?
For continuous insulation.
No, but do you need it for fire resistance?
Well, we have cement board on top, which would.
I know that, but based on the rating of you're going way back to your construction type, and what's the exterior wall rating? Do you need?
They're type 4 up there, aren't they?
Do you need a non-flammable assembly that includes insulation?
Do we need that for Type 4?
God, I can't recall off the top of my head. Let me.
I can't either. I thought you didn't, but if you do, then it makes sense. But if you don't, and you're encasing this in cement board anyway,
yeah, we could.
I guess you could have fires. I mean, that was the problem in London. The fire spread through the insulation in part, right?
Mm-hmm.
But if we have fire blocking, we wouldn't really do anything.
That would help. That would help. But my point is simple, that some of the other insulation types, even though they may have a flammability issue, will give you higher R values. But I don't, again, we haven't run an Insight 360, but you did already study the ASHRAE code. So you guys are making the ASHRAE code requirement?
ASHRAE 90.1.
Are you making it, right?
We are, yes.
Yeah.
Okay. I'll give you just a little bit of a hint, because unless you're going to do a therm model, you may want to extend a little bit more insulation in that parapet.
I agree.
Not a lot, but I don't know, another 6 inches or something.
Take it up to the flashing and counter flashing. Bring it up and down again to close that loop.
Yeah, just buffer it out a little bit, clean it out.
Now, so if I can ask, now remember our conversation a moment ago about exposed, honest systems, and here's a case where you're concealing, right, the wall. So is that gypsum board intended as a constant or no, like an alternate? So I would amend that note.
Okay.
Or maybe show it as dashed beyond, like,
and have it as
required or as specified or something that calls it out as an unusual condition, not a constant.
Yeah, because we wanted to pick a section that had the parapet.
Yeah.
Because that was kind of important to us, and that wall in particular actually did have the drywall. So
okay, so let me talk about one more thing: gravel ballast. So that's another expense that.
Yeah, we could do EPDM.
Yeah, I just feel like the ballast is what I would specify you guys if I was going to have occupants looking down on the roof and wanting to see this roof as a foreground condition that's like beautiful and appropriate for like a condo development. This is not quite that. This is apartments. Plus ballast is expensive.
Okay.
It can get blown off the roof. Have you thought about just adhering the roof and dispensing with the ballast?
We're thinking on the roof plan, there's a note that talks about the finishing on the roof with respect to gravel as well as pavers, because the lower roofs will have occupants going out there and experiencing the space there. So we wanted to, but then the upper roof is.
But you could cover that with paving elements over a
right.
roof. You don't need to gravel.
Okay.
Right.
But like where you have hardscape, whatever that material is that you use to occupy the roof with, you can hem that in. You can border it with planters that have grasses in them so that you don't necessarily see the gravel. I don't know why I have a big antagonism towards the gravel roof. It's just that it's just an expensive proposition. It's a different roof approach to everything else that you're doing.
Okay.
I might think about it, doing it the same way.
All right.
I mean,
Dan, what's your thoughts on that?
I'll just tell you, in a lot of projects when I'm working in firms, and I still advocate to students today, is look, you know, if you have multiple trades working on the roof, you've got multiple problems.
Okay.
If you have one trade working on
streamlining it,
you know where to go.
Yep.
You have one person to coordinate, and you know who's responsible for it.
You know, and then when there's a leak, not if, when there's a leak, they got to get rid of all that gravel.
Okay. Yeah.
You know, and repair it. It's just like, oh my God, what a headache just for certain people to look down on it and appreciate a beautiful like foreground landscape. It's just like, was it worth all of that? Was it worth this callback?
Okay.
Now, I think a Firestone roofer a roofing rep might have a different take on it, but that's kind of like the feedback I've been getting over my many years.
Okay. We'll revise that.
Yep.
Can we go back to the wall section? Yep. I want to say that these look really good, by the way. So
yeah, these guys, you're doing very well on this.
I really love the way these are like playing out. I'm seeing the datums. I'm seeing the materials drawn graphically in section, right? I'm seeing windows sitting in the beef of the wall, not in the insulation. I'm seeing clips tied back to the structure.
Guys, I keep in mind I got to see headers above windows.
Okay.
And I have to know that there's something as an exterior finish on the back side of the parapet.
Okay. Yes.
Or the roof runs up, but you're showing the counter flashing and flashing. Yeah, so you need some sort of material. It could.
Yeah, I don't know. I mean, it could be anything. It could be more cement board, but something.
It could be cement board. It could be vinyl siding. It doesn't matter.
Yeah, I think the note's missing.
Yeah.
It looks like there's something there, but just the note's missing.
It could be the roof. I mean, the roof can like extend all the way up to the coping.
Yeah, if it's a big single ply, just pull it all the way up.
That's a different detail, but it's a detail that you can quickly illustrate by modifying this detail.
Right. So, and again, please, lintels above windows. Remember, heads do not connect back to the underside of the lintel. Okay. Heads float under lintels, right? But looks like excellent work in terms of developing this, and you're cognizant of your insulation values. Seem to be cognizant of some of your issues like thermal breaks. Yeah, can you zoom? I'm sorry. Stay where you are. Go to the right to that little wall section detail there. Move over and zoom in on that right there.
Can't zoom in any further.
Zoom it. Okay.
Yeah.
Well, you understand there's a head issue there, lintel issue there. I don't know quite how that wall or something is going to float on that, right? There might be a flashing issue in there too, right?
Yeah. We'll touch that up.
Okay. Yeah, there's that needs some detailing.
Okay. And it looks like there's like a little concrete sort of small mini wall below the.
Yeah, well, we wanted to put in at least a minimum a couple of inches of ledge because of snowfall and stuff like that. Yeah, stones. It would be a nightmare for flashing.
Got to have. Yeah, there's things we got to clean up.
Yeah, it's still.
Right. So
you guys are in good shape.
Values coming out? Are you guys meeting the ASHRAE 189?
90.1 for sure. I can't say if we're meeting 189 or not.
189.1 is the research we did at the beginning with Andrew. You guys are supposed to be using it.
Yeah.
Yeah. Okay.
You guys are also doing the energy modeling that Dustin talked about last week, right? You guys, that's one of your options. Yeah. So you should start processing that.
Right. Okay.
I'm glad you're doing that one.
Yeah, we were gonna run it and then see where that sort of lays us out, and then maybe we end up saying, "Oh, we really have to add more insulation."
Yep.
And I do want you to do the following when you start collecting those runs, right? because you saw what Dustin had. He had his initial run, and then he has the ability to make modifications, right?
Okay.
On the fly.
I want you to document every one of those modifications that you make and see how you're clocking down, so to speak, in terms of your energy utilization.
Yeah.
Okay.
You know what I'm getting at?
Yeah.
So you say, okay, here's my initial run. Then I do this, and then I do that, then I do this, then I do that, and this is how I get to where I'm at the end, right?
Yeah.
Okay.
Want to see how that's documented
Okay.
and understood, because basically, you know, again, someone's going to put that image on the screen and they're going to say, and here's what Insight 360 told me about this, and then there's going to be a pause and no one's going to say anything, and we're going to wonder why it's there, right?
Yeah.
But you're going to tell us what you learned from that.
Okay.
Yeah.
So just break down.
That's what everyone needs to do, correct? That makes sense?
Okay.
Yep.
Okay.
I believe that's our last slide here too.
All right, good. All right.
Yeah, I enjoyed that. Thanks, guys.
All right, guys.
There's one more.
Elevation.
So this is the blow up elevation with the floor plan detail and the wall detail being.
All right. I love it, except I would really love to do an alternate version of the wall section on the left that shows me your balcony.
Okay.
Yes.
We're actually working on that.
Okay, great. Thank you.
Okay. Thank you.
I don't have anything else for them. Mark, do you have anything?
No, I'm good. This was enjoyable and informative, and I hope that everyone found some value, right, in the discussions that we had with each of you. So we'll continue with the other three groups in similar fashion, Dan,
Yes.
on Thursday night.
Yes, please.
Also, if you have not looked at the material that Professor Farrow shared, please start doing that now. You need to be accommodating that information and integrating it. Also, if you've not watched the Larry Scarpa lecture, which is available online at Lawrence Tech, you need to watch that, because his projects and his approaches are so coincidental to your own work. And then lastly, I did share with some of Dan's students. I think it was Candace, Dan, that I shared Dustin's lecture with. So I asked her to share it on with all of your students, but I think you went ahead and did that as well.
I sent it to our students, Mark.
Okay, good. So the lecture that Dustin gave is also online if you need to revisit that.
And he will answer questions you have too.
Yeah, he would love to hear from you, right? So if you have questions, shoot them to him.
And I was really glad to hear that students are interested in what he does. Last year he taught that class in spring. He had 6 students. This semester has 23.
Amazing.
And I don't know what Professor Farlow's thoughts on it, but my impression has been
that's cool.
I was the kind of guy that in 1977 was going to solar fairs, solar energy fairs, and they were talking about their hot water and hot air systems and all that, and so I'm not just one of these people that kind of glommed onto the sustainability wagon recently.
No, you're one of the real McCoys.
Long timer. Okay?
Yeah.
I won a passive solar residential design competition as a student years ago. So I've been around a long time, and I will tell you that the most serious attention to these sorts of issues that I've ever seen has been in probably the last 7 to 10 years.
Because energy costs are just crippling households and businesses.
And because the science community and the industrial community has realized that they need to do things differently, and they have a different understanding of natural systems and the impacts that systems we've used in the past has. So I don't see it. I guess I know maybe Professor Farlow disagrees, but I don't see it diminishing.
No, I see it continuing to become completely unreasonable, and a real concern, and a real concern.
Yeah, it seems to be growing. And so I think it is important for you guys to have the familiarity with it, would be my point.
Okay. Anyone have any questions?
All right. If not, sorry we ran late.
Okay. Thanks, everyone. We'll see you on Thursday.
See you later.
Quick question, Mark.
Sure, go ahead.
Time this weekend. You know how we spoke about opening up that corner on our removing the column and stuff like that.
And
However, I'm not remembering it with you.
At the last review, we talked about it.
Let me open it up on mine.
Please.
I can
On
He
John?
had the turret as a reference.
Yeah.
You want to give me 1 second.
Do you want to show that?
Oh, vaguely I'm remembering that now. Thanks, Nathan.
Here we go. Let me share my screen really quickly. Share. Okay, so we had this.
Yes.
We said we started talking about opening up that corner.
Yeah. Oh, this is a good model.
1 second. Sorry, it's just very slow right now with everything that's kind of wrong view.
You might need to turn off some of your porn while you're, firing through this, right?
No, that's you. It's your computer. Yeah, so we're looking at what's it called? Putting in a bunch of smaller columns and infusing them into our glazing to make it look as we're using those columns as mullions.
Yeah.
At that condition.
Yeah.
Any thoughts on if that's the way
So what's happening? Can you zoom in a little bit? What's happening? Like, I see.
So right now, this is a still work in progress, right? Like these columns are too big.
The main issue that we're having is how do we cantilever the balcony while removing a column in the corner, but not adding a column on the outside of the balcony and not having a thermal bridge. We're trying to balance all these things. Like for the last 4 hours, we've been bouncing ideas back and forth. So we're wondering if we could have like a sit down at some point and like talk about it, because like
sure.
Yeah, over this weekend.
Sketch and
It would help if, for my sake, if you had like a couple of views like this, maybe as screenshots, and then a couple of plans cut.
Okay.
That show structure and the normal line of the building, and then the cantilever, right? The balcony edge.
Okay.
If we could look at that. I would even be amenable to looking at that a little early on Thursday or staying late on Thursday, or we could look at it later this week.
I was thinking maybe Saturday, because I've got a few other things for the other classes that I have.
I'm good with that.
And then, so I'll prepare. We'll sit down.
Are you on campus at any time, Mark?
Saturday? No.
Or like any.
But
I will be on campus Thursday before this class. My other class finishes up around 5:15 to 5:30.
I'm not going to. Well, what should we do?
No, I won't have time to finish it
How
up.
about on Thursday or Saturday? Yeah, Saturday.
Let's do Saturday.
Saturday works. I wasn't planning on being on campus.
Well, not necessarily on campus.
But actually, because like last Saturday, I had a couple of things, and it ended up being that I just wasn't able to be on campus. But I wish now that I had been. So I can try to be on campus if that seems agreeable to both of you.
If we get enough views and then the floor plan, I think,
we'll try to get 2-3 options done, and then we'll send you in.
Okay.
We'll send you an email.
It's like, let me say this: it's easier for me to be on campus than you, because you got to come across the river. But if you could send me things on Friday, A, to let me look at them overnight, and then B, to fine tune when we're going to meet on Saturday, then we can talk about if we meet on campus or not.
Okay, that sounds like a plan then.
Perfect.
I'm going to make one quick observation, and I think I had sent you some materials of like metal screening used for shading, right, and privacy.
Right.
If you notice, I think Larry Scarpa's lecture maybe even shows a project like that. Sometimes they just cover the whole wall.
He did do that. That's cool.
And then they punch out the areas where they need to have the opening.
Okay.
And what I'm getting at is you're kind of handling it on a floor by floor basis, right? Where you wrap the screen around the balcony. But what I'm saying is you see the bottom of the top balcony.
Okay, yes.
The handrail of the balcony or guardrail of the balcony below.
Mm-hmm.
Imagine that's all one surface.
Yeah.
Okay.
Right. And then you start punching out where you need to.
Okay.
That makes sense?
Yeah.
That's what I'm starting to see now is another way to look at these. And it may add some continuity and may give you some different characteristics that you might find desirable, but you have to ask a question if you want to think about it that way.
Okay. Yeah.
Right? Rather than being horizontally wrapped, which is most of your building, now if you want to articulate that corner
or emphasize it.
Yeah, or emphasize it. Maybe the vertical piece with punches in it is another way to do that, like the turret, right?
Okay.
Exactly. Yeah. We were talking about that too.
Yeah. That was one of the options that we wanted to draw up.
All right, that's just passing that on. And
cool.
I think that I've sent you guys some examples. You might want to look at them.
Yeah, we did.
Yeah, we saw that.
That's why we wanted to revisit this.
Yeah.
Okay.
Up a little bit.
All right, good. All right, that's it. For me.
All right. Thank you.
All right, have a good week, guys.
Thanks, everyone. See you soon.
Thank you.